should have that one and that one. Think right. I think we're here. Got a minimal panel so far. I've only got Blue, John, and me, myself and I. Oh, that's 6 people. 1, 2, 3, 4, 5. No, it's 5 people. Sorry. Hey, Mira, Little Wolf. Who else is out there? Flow Rider, Point Laugh. Sean, I've got no idea what you're talking about. What's the link you got there? I've only got Blue, John, and me, and myself and I. Okay, who's? I can hear something. 1, 2, 3, 4, 5. No, 5 people. What am I hearing? Hey, Mira, Little Wolf. Who else is out there? Flow Rider, Point Laugh. And Sean, I've got no idea what you're talking about. What's the link you got there? Have you got the YouTube going, Blue?
Yeah, let's see what I get. Hang on. There. Sorry, that was me.
Okay.
My bad.
That's okay. You received a fine in the mail.
Yeah, check to follow.
Well, nothing really interesting has happened in the last couple of days that I know of. I did want to talk about something else, but the other person's not here to talk about that. But I did notice that the Flat Earth debate had, who did they have? Gleam versus an SOS. Is that Science and Satire? That's usually Team Skeptics group and Conspiracy Cats and all them. That's what I thought that'd be. And okay, play a little bit of that somewhere, and we'll see where Gleam's wrong again. How do I do that? I'm learning. Alan told me to use the transition thing. And look at this. This is another trick I learnt. See, I can move Blue up to there, and now Blue's on top. Okay, I do that. Yeah, there we go.
He's on the bottom for me.
Is he down the bottom? Yeah, no, let it change.
Yeah. Ah.
Why change where? In Zoom? It should have changed.
Oh, there you go. Yeah.
See?
Yeah,
Look,
you're
see,
right.
I put Blue up top.
Right.
I can move them all around. It's weird that.
Yeah.
Clever.
Yeah, just.
I'll when we get a few more people in here, I'll try it one day just to trick people. So we'll go to that. Go to that. Transition that. There we go. And then, but the only thing is, I keep forgetting to do that. All right, that gives me that, but then I'm left with. That's where I usually put that. Okay. We get a.
Or hundreds of those. How many we got people watching? 320 odd. Okay, yeah, no, that's good. That's good. So let's just pretend that we got 100. Oh, there's another yes. But either way, let's just pretend we got 100 versus 1. Yeah. So that seems a good ratio in my eyes. And you both said no. Okay, now I'd like you to play the video. Please don't get offended, Craig, by what I've done here. But either way, it's going to be a fun. But
I've been transvestigated no less than 17 times. I don't get offended by flat earthers.
This is nothing to do with anything to do with any sexuality either. This is more to do with only English people will probably get the joke, and Craig, you'll get it more than the Americans because this character is known for a stumbler and a yeah but no but, and you'll understand when you play it. But either way,
it's Vicky Pollard, isn't it? Yeah,
it is. Yeah, it's exactly that. Can you? Yeah. What I will say is there is two two false endings. If you would like to just keep it playing until it actually stops, I do have a plot twist. So I'm going to hand it over to you then, and then let's say I've had 10 minutes for my start with, really.
Okay, so the easiest one's going to be the Paul Dirac statement, because you're using that out of context. What Paul Dirac was saying is he was defending the theory of the ether. He wasn't saying that we should, that he believed it was right. He just felt like it was.
Right, yeah, here we go, guys. This is Gleam. I'm just going to play the new Science of Satire intro once more, and then we get the video on.
Oh, that's loud. They like to crank the sound up, don't they? Headphone warning.
Hey, fight. I don't know why, but it keeps pausing. Yeah, it keeps pausing coming from your end. Even when you were playing the intro video, it was pausing coming from your end. Like it was. Go ahead, try on your output to me, to media.
What's that? Does ether exist? Mass Neo something relatively Lorentz ether theory. Quantum foam virtual particles. Is this what it's going to be like, this whole debate? By the look of it.
Don't know.
That was it.
Can you just give me a citation to back that up?
I'll pause it so we can read it. So is this an actual citation? The ether invented by Isaac Newton, reinvented by James Clerk Maxwell. This is the stuff that fills up the empty space of the universe. Discredited and discarded by Einstein, the ether is now making a Nixonian comeback. It is really the vacuum, but burdened with theoretical ghostly particles. But didn't they talk about this in the dark matter sense as well? Like, isn't that the same conversation to do with dark matter? But that's what I was led to believe. Credentials, whatever that is. That's either National Medal, Discover, Nobel Prize, Director, something. That's another citation. I can't read it. We can now see that we may have very well have an ether subject to quantum mechanics and conformable to relativity, provided we are willing to consider a perfect vacuum as an idealized state, not attainable in practice. From the experimental point of view, there does not seem to be any objection to this. We must make some profound alterations to the theoretical idea of the vacuum. Thus, with the new theory of electrodynamics, we are rather forced to have an ether. And that's a guy called Paul Dirac. 1951. Well, going back a bit.
Yeah, for sure.
Anyone a bit more recent? I'm sure there's been more recent studies. citations. Okay, third one. Oh, this is still from 1988 though. Approach of Einstein differs. I mean, these are one people I don't even really heard of. They're like not the main scientists that I look at and go, oh yeah, I've heard of him. The approach of Einstein's differs from that of Lorentz in two different ways, major ways. There is a difference of philosophy and a difference of style. The difference of philosophy is that since it is experimentally impossible to say which of two uniformly moving systems is really at rest, Einstein declares the notions, really resting and really moving, as meaningless. For him, only the relative motion of the two can be uniformly moving objects is real. Lorentz, on the other hand, preferred the view that there is indeed a state of real rest defined by the ether, even though the laws of physics conspire to prevent us identifying it experimentally. The facts of physics do not oblige us to accept one philosophy rather than the other. Okay. What's this brief history? Ancient Greek ether of upper air, Newton's ether absolute framed, Maxwell's ether for classic electrodynamics, Lorentz ether theory of electrons, Michelson-Morley experiment, I've heard of that, Neo-Lorentzian relativity, Einstein spacetime new ether, Paul Dirac's Dirac-C quantum electrodynamics, Feynman's virtual particles, John Wheeler's quantum foam, a collective medium of virtual particles. No, I don't want to get into more. I just want to hear these. I reckon he's either cherry picked or he's misunderstanding any of all this.
Believed in space-time. Space-time is the same mathematics as ether. That's what I'm telling you.
Yeah. For Christ's sake, Jesus. I don't even know where to...
Let me tell you the back history. It's in...
Please, it'll be very entertaining.
If you go to Ether 1, which is slide number 9.
GE, thanks. Thank you. Thank you. That road trip was worth it.
But then fast forward to 1951, Paul Dirac, the father of quantum electrodynamics, he's in Nature, saying that you have to accept there must be an ether, there must be a background radiation or 0 point energy.
Okay, so a guy that I haven't heard of said something.
Paul Dirac.
So, yeah, I haven't heard of him.
Yeah, 1953.
Okay, that's done. So I hope you got it. You don't need to counter all those other citations. Those were just that we can go through if you want to. But it was just those 3 to start with, really.
Okay, so the easiest one's going to be the Paul Dirac statement, because you're using that out of context. What Paul Dirac was saying is he was defending the theory of the ether. He wasn't saying that we should, that he believed it was right. He just felt like it was unfairly or prematurely dismissed by science. Now, just because it was prematurely dismissed by science doesn't mean that it's right.
Okay.
Hold on one second.
Sorry.
It doesn't mean it's right. Now, I believe Paul Dirac said that sometime in the 1950s. Since then, we've continuously done more and more Michelson-Morley experiments, and I'll just read a few of the dates after 1950. Louis Essen did one.
2 seconds.
Satterholm.
2 seconds. No, if I can just stop you there, I don't think you've grasped it there. Then, I mean, number one, Louis Essen measured the speed of light accurately, but he was completely anti-Einstein. I don't know whether you know him at all.
I'm just citing the other experiments since Dirac that have been done for the ether.
If we can go back to the first citation, because that citation is actually from 2006, so that's pretty recent, really, 14 years ago. Now, there's two things you've got to understand, and when I said at the very beginning, yes, ether does exist in forms of, or when we're talking mass, you can use Lorentz or neo-Lorentzian relativity, which is the same mathematics as space-time, okay, for mass, for the warping of space-time, basically. But when we're talking light, as in SR, there is this background medium which Dirac himself put together a theory but died before he could complete it, and it was called the Dirac sea. And the Dirac sea was a sea of negative electrons, which was identical or virtually identical to Lorentz's theory, which is the theory of electrons, and his ether theory developed from the theory of electrons. So I don't think you get the, whenever they're doing these interferometer tests, they're confirming both mathematics, because both mathematics are, I mean, can I just ask what you think Lorentz transforms are? That is probably the start, because that is the core fundamental part of relativity.
Yeah, well, Lorentz transforms are transforming from one reference system to another. So basically, you know, you have the way length. The easiest way to explain it is like kind of like a space-time globe, right? Because that's how they showed it in the video. So you have, you know, your time, your world path. You know, that's your world path through space-time. And then you on one axis and time on the other axis. And depending upon whose point of view you're looking at the rest of the universe from will depend on how they appear to be moving through space-time relative to you. And that's what these transformations show, is how moving from one reference frame, from the viewpoint of one reference frame to the viewpoint of another reference frame, will change how you see each object. So it describes relativity. It describes how something appears, how something, whether it's velocity or length, you know, how time, any one of these relative concepts that shows how they transform when you adjust from one reference frame to the next.
Yes, I very much agree with that, and that was spot on, well explained. Yeah, okay, I understand that, and yes, I agree with that. Now the next question is the more difficult one. Why did Lorentz invent his transforms? This is one thing that a lot of people do not know.
I mean, off the top of my head, I wouldn't know. I'm not a physicist or
it's cool. No, that's
physics
cool.
historian. So, to be honest,
none of us
with you,
are experts.
I don't know exactly why he came up with the transformations. I believe it was to replace another mathematical transformation from at the time.
Yep. No, that is right.
Wasn't it
That
the
is right. As
replacement of Maxwell's equations?
No. What Maxwell did is he figured out the equations for electromagnetism. Now, how it then split off is Heaviside then figured out the component of the magnetic side, and Lorentz figured out the electric side. But without wandering off, going back to Lorentz's transforms, Now, it may shock you to know, and this may be something else that you may learn, and it may be something that you'll have to go away and just double check that I'm not bullshitting you. Yeah, but Lorentz transforms were created because he wanted to keep the ether, his Lorentz ether theory, alive in the threat of it getting deleted from the Michelson-Morley experiment. Okay, so just to reiterate, you can actually go to I can't remember, if you go to, it's probably about 4 or 5 slides from here, Craig. It goes through the history. I've told the history here, and this is as I understand it, or as I've researched it. Next one along, it would be the
What was the Michelson-Morley one? That wasn't the canal one, was it? That was something different.
No, Michelson-Morley. We're trying to actually measure the ether wind, so to speak. They were trying to.
Okay.
That's the famous original interferometer sort of experiment.
Okay.
the very next slide. There, brief history. So as I understand it, and if I'm talking crap and you can cite me, then seriously jump in. But ancient Greek ether was the upper air. This other.
If Gleam is talking, he's talking crap. Believe me. If words are coming out of that man's mouth, it is crap.
Well, they didn't say it on here though, but we all say it then. Yeah, we'll answer it. We'll answer his question.
Oh yeah.
Element, this other other thing, but either way, we'll skip right to Newton. Newton had his luminiferous ether, which was absolute framed. We all know the story, I'm sure. Maxwell used this ether and he actually advanced it for classical electrodynamics and creating the Maxwell equations. Then Lorentz had his ether theory, which was developed off of the theory of electrons. Then Michelson-Morley done their experiment, and
if to not really bother about going any further into this, if I get the point that Gleam is a proponent for bringing back that the ether is what's out in space.
Oh,
is that?
Yeah.
Okay.
Yep. I think that's a fair statement.
Okay.
Because
haven't we moved on from that, and we actually thought about dark matter and things and something like that, and string theory and all these other theories, all those types of things as well?
There is no ether as far as we know.
Mm.
That's been set aside time and time again.
Right.
It was something that they thought had to exist. That's sort of the history of things. It was assumed, just because we know how we knew they had figured out that light behaves like waves, right? And when you throw a rock in a pond, you see the ripples in the wave, move out, etc.
Yeah.
Well, if light behaves like a wave, water's waving, you get the waves in the water. What the hell waves with light? You need something to wave if you're going to have waves, right?
Mm-hmm.
So that was the ether theory. That it was the ether waving. That light needed something to travel through. So the thing it needed was ether.
Okay.
And Michelson-Morley set out to measure that the speed of that ether wind, so to speak, as the Earth rotates and travels, in its orbit around the sun. You should be able to measure the ether, the movement of the ether.
Wow.
Now, this was a real problem for physics, because when Michelson-Morley did their experiment and they couldn't find any damn ether, then you've got a problem. We know that they already knew it was not questioned whether or not the Earth was rotating or orbiting the sun, or et cetera, et cetera. They knew all that was happening, of course.
Yeah.
but you can't find, there is no ether. Uh-oh. Now what? So you've got to adopt at that point one of two contrary positions. It either has to be that the earth is stationary and unmoving, which is unthinkable. We know that's not correct. Or ether doesn't exist. Oh shit. And that was a quandary that existed for 25 years or so from the time of Michelson-Morley's experiments to the point in time that Einstein came along and finally explained everything.
Oh,
So that's sort of the way that went down, Terry.
okay.
But I'm sure somehow or the other, Gleam has managed to box this entire thing up.
Well, he's got some pictures or some drawings and another citation thing here. Well, you must be citing something, and then I'll go through this bit. See what all this is.
Yours.
Not yours.
It's a bloody medium, for God's sake. Oh my God, it's a scalar
It's not.
medium throughout the whole universe.
No, is it a scalar or is it a medium? Which one is it, Gleam? They're not the same thing.
Well, it's the scalar. It's a scalar across the whole.
So it's not a medium, then?
I see it as a medium.
I don't care what you see it as. You can't
the
say it's a
medium is
scalar
the
medium
virtual
because they're not.
particles,
No, Gleam,
quantum
stop. Gleam, you do not get to redefine science. You can't say it's a scalar medium because they aren't the same thing.
Show me a citation, please.
We just did, actually.
No,
we
you didn't.
literally just did.
No, you didn't. It said
Just-
it's
just-
more
yeah, no, we did.
evidence
Just
for
because you don't
Einstein's
understand
new
it.
concept.
Which is
again
space-time.
not-
Which is
not
space-time.
the luminiferous ether, you fucking dipshit.
Oh my God, they're mathematically identical.
No,
for God's
No, they're
sake.
not.
He
No, they're not.
he rejected the ether, the luminiferous ether.
Yes.
No, he rejected the luminiferous ether and replaced it with space-time. Okay,
They're the same
four-dimensional
thing
space-time.
mathematically. They're the same thing.
No, they're
Okay,
not.
so show me how
They
to.
resolve
Okay. Simple question, please.
Citation
show
number
me.
3 on mine.
Let me ask you a question.
You mean cherry
I
pick
need
number
you.
3?
I need to know what this.
Citation.
I need
No,
to know
cherry
what the.
pick. You didn't make any citations.
Listen, guys.
Sorry, team.
I need to know what the Schwarzschild's radius of the Earth is using the ether mathematics.
I don't know. It would be the same outcome. Listen.
No, you can't. No. No. I want to see the math. I can show you the math.
Show me the math, yeah.
I can show you the math to
outcome.
support mine.
It would be
All right,
the
Gleam,
same
I've got a question for you.
outcome.
In which equation, Gleam, in which equation is ether something we take into account in gravitation, motion, momentum, photonics, photoelectric wave
Anything.
functions, or anything?
Anything at all. Any aspect of physics. Where do we take it into account?
Because
Okay,
if we
then-
don't, you're wrong that the maths is the same.
Okay, so we take it into account in the magnetic moment of the electron. There we go. In the Casimir effect. There we go.
In the hold on, no, because now you're talking about. I pointed out why your definition
Again,
of the
didn't understand
Casimir.
the context.
Hold on, I'm going to show it to you right now, okay? Because I would rather just show it to you, okay? All right, I'm showing my Paint 3D.
I know it.
Okay, look, we got a plate and we got a plate over here, right?
I know it.
Now, hold
Hey
on.
guys, you want to hear a funny story?
Hear,
while we're all
hear me out.
chatting
Hold
here?
on.
I'm
Hold
dating
on.
a first grader.
All right, so we have
All right, Nathan,
virtual
shut up.
particles that happen here, and they're of different wavelengths. You have to excuse my different waves or whatever.
Particles?
Hold on. We got different wavelengths. They all exist out here, okay? Now, when these plates are far enough, we have the same density of particles on the outside
Yep.
as we do on the inside. So the pressure from these particles pushing this way is equal to the pressure pushing this way. And we'll just say the same thing is happening over here and pushing things. Now, once we start bringing these plates together, these longer wavelengths cannot exist between these plates. So now we're going to change colors. And we're going to bring the plates to like right. Whoops, that was stupid. I wasn't changing colors. All right, so now we're going to bring the plates to like right here, right? So now we have these smaller wavelengths that can exist inside of here, but the longer ones, like these, cannot exist outside of here. So now we have a particle density on the outside of the plates that is greater than the particle density on the inside of the plates. So the pressure on the outside of the plates is then greater than the pressure pushing out. And these plates then begin to push together. Now, if what you're saying is correct, okay, all of these virtual particles have the same wavelength. They're all positrons. They're all positive.
No.
You said multiple times they're all positrons.
No, it's antimatter. You liar. It's all antiparticles, you idiot.
You have said multiple times
said
that what has made up.
Positron was the first one that was found that was predicted by Dirac in 1933, won a Nobel Prize for it. And then Carl Anderson electron microscoped it because I was corrected on that. Remember? Carl Anderson got a photo of the positron. And that is the existence, that confirmed existence. No, it was bullshit. I said all virtual photons and virtual particles, as the first citation says, are the ether.
Right, I mean, you know what?
Antimatter
what is a virtual particle?
is
I don't
ether.
think you know what a virtual particle is.
A virtual particle is something which bounces off when there is something like beta decay, let's say. So a virtual particle, a positron, when something would
just
decay.
Stop. No, that isn't what a virtual particle is. Not in the fucking slightest, Glean. No, I'm stopping you right there because you don't know what a virtual particle is. A virtual particle is simply a fluctuation in a quantum field, and it seems to exhibit characteristics that are similar to a normal particle, but its time in existence is limited by an uncertainty principle. That's what a virtual particle is, not what you're talking about. Honestly, you are not describing a virtual particle in the slightest.
Pull up virtual particle. Pull up virtual particle, please.
I'll do it while y'all.
Virtual particle on Wikipedia. Let me see.
What do you want to know
pretty much
about
says
it,
what
though?
I said.
They use the positron as their key.
So I'm going to read from Wikipedia on virtual particle. In physics, a virtual particle is a transient quantum fluctuation that exhibits some of the characteristics of an ordinary particle, while having its existence limited by the uncertainty principle. Team, isn't that exactly what I said?
Yeah. But I still want to...
Gleam, you don't know what you're talking about.
But Gleam, let's get back to what I asked you earlier. How can you use ether theory, replacing general relativity with ether theory? How can we use that to be able to predict the Schwarzschild radius of the Earth?
It would be identical to your space-time.
If it's identical, what makes it different?
Nothing. That's
then
what I've
why
been trying to
are
get
you
to
arguing?
For 2.5
so
fucking hours.
If Einstein calls it space-time and you call it ether, are you really just arguing for? Are you petitioning now for the scientific community to change space-time to the word ether?
No, because listen, right? Listen,
yes,
you're not kind of getting this bit. No, just don't interrupt for 10
you don't
seconds.
Understand anything.
Well, let me point this one point across.
I'm going to interrupt you because everything you say is fucking stupid.
Oh my god. This guy is a
I'm
big
sorry,
baby.
Gleam, but everything you've said is so ass backwards.
Well,
you are
let me try and put this in
cherry-picking
simple
little
forms.
moron with nothing more. You do not understand any of the
personal
context.
attacks
You don't
because you've got
understand.
nothing,
No,
have you?
no, not personal attacks. Facts.
You've got nothing,
You don't
mate.
understand any of the context. You don't understand any of the
Why are you
maths.
trying to silence
keep
me
saying,
then? Why don't you let
Gleam,
me hand myself?
Gleam, you keep
I'll
saying
let
the
you
maths
talk
is exactly
after
the
this.
same.
Go ahead.
Gleam, you keep saying the maths is exactly the same. Show me the fucking maths or shut up.
All right, Gleam, go ahead.
Right, ignore that request because I was just about to say something. You have just shown me virtual particles, okay? Einstein said that that medium was not there. So positron was the first detection of that medium to say that is there.
No.
Now...
That's not how any of this works, Gleam. In the slightest.
Okay, so what are virtual particles then, if not the ether? Come on.
I just told you what a virtual particle is. It's a fluctuation in a quantum field.
It's quantum foam, exactly that. It's the excess
it's a
energy.
fluctuation in a quantum field. It is not a positron.
Energy.
You
Search
don't
on
know
the
what
virtual
a virtual particle. Gleam, you don't know what a virtual
Absolute.
particle is.
Absolutely.
Are you saying that my description of virtual particle is wrong?
No, it's correct.
Right. Well, then you don't know what you're talking about because everything
Well,
I'm
how
saying
come?
disproves
Well, you
what
tell
you're
me.
saying.
Because
How
you
come?
can't.
Tell
Okay, so everything you're saying is exactly what Einstein says it is, but Einstein doesn't call it anything other than special relativity and general relativity. When I ask you
Yeah.
what is the difference, what makes your idea or your theory or your what you're trying to present here tonight, what makes it unique from general relativity?
Because general relativity assumes there's nothing in the medium, and there has been proven that there is something in the medium. And what I'd like you to do on that virtual particle page is go to vacuum polarization, which says, which involves pair production or decay of the vacuum, which is a spontaneous production of a particle-antiparticle pairs, such as an electron-positron. You don't know what you're fucking on about, Craig.
No. What Craig said was that.
Virtual particle. No, but he's telling me I'm wrong. And he says it's got nothing to do with
No, because
positron.
you're saying
Come
no.
here.
What
No,
he's saying
go
you're
down
wrong
to it
about.
now and
He's
show it
saying
on
what
screen,
he's
please.
saying you're wrong about is that you're saying it's just coming from the ether. You're saying
he's-
that's the ether.
He said it had nothing to do with a positron. Load it up, please, and you'll see. A
One
virtual particle is
thing
an-
about virtual particles is that the virtual particles can exhibit characteristics that are
Stop
similar
backtracking, just
to
load it up.
shut your mouth, Gleam. It can exhibit things that are similar, characteristics that are similar to what you would get in an electron-positron pair. All right?
Bullshit.
They're
It
not
is
saying that it creates electron-positrons, and they're not saying that the aether is positrons. You don't know what you're talking about. These are all variations of quantum fluctuations. All these things that it lists are just variations
Spontaneous
in the
pair
quantum field.
production. You explained. That's all. That's all you explained. Spontaneous pair production.
Yeah, as one of
Which
the
is been
characteristics that
evident.
as one of the characteristics that virtual particles can exhibit. That's all. It's not saying that it
But
is.
you just said it had
literally
nothing to do with
elect-
positron, so I don't know what I'm on about. You're mad.
No, you don't know because it's not positrons, Gleam. You are not looking at the context of what you're reading, right? It's not saying that it literally creates positrons and electrons. It is saying that they are manifestations of the fluctuation of the quantum field that can exhibit
Okay.
characteristics that are similar to an electron-positron pair.
Hey,
you
Gleam-
don't know what you're talking about.
Gleam, let
in
me.
the
I've been sitting here trying to think of a good way to ask you a question that would help you to delineate between the two, and I think I have a good one. Okay, so let's say I put a magnet on the end of a stick, all right?
Yeah.
And I take the magnet above my head and I start going up and down with the magnet, all right?
Mm-hmm.
Photons will be kicked out of that magnet, okay? Now we understand why it does that because it's a moving magnetic charge. It generates a moving electric charge, which in a turn generates a magnetic charge and an electric charge and so forth. It keeps going on and on. It's a self-perpetuating wave. In fact, that's what a photon is. So how is that consistent with ether theory? If I take a magnet and I put it on a stick and I move it up and down, if light's not really electromagnetic waves traveling through the electromagnetic field, despite the medium around it, how do you translate the ether into that observation?
It's to do with the virtual particles. Everything
You don't know what a virtual
from.
particle is, though.
Oh, I've just
You don't
proven
get to
you
talk
don't.
about
Well,
virtual
hold
particles, you don't know what they
on. Let him answer. It's a deal with virtual particles. Explain.
Okay, so the magnetic field as we understand it today, which thank God for Paul Dirac and his works on absorption and emission in atomic
That you don't
theory.
understand.
Well, either way, it then led on to Feynman recreating it as virtual particles. Now, virtual photons are emitted in magnetic fields because of this. And it's in that same document of virtual particles. They're the exchange
It's not a
particle.
document, that's Wikipedia.
But
Okay,
you
well,
still
it's a
have not.
document.
You
God,
still
thanks,
haven't
stop being
answered
anal.
how a photon gets created from the ether due to a moving magnet. Now, if we know from
Will it be
our
1 to 2
understanding, well, hold on. From our understanding, for what mainstream science says, okay, is that we have an electromagnetic field around us, And when you move a magnet through the electromagnetic field, when you have a moving magnetic charge through that field, it generates a moving electric charge. And those two things become self-perpetuating. So it doesn't mean that like it kicks one out into the universe. No, it just generates a charge, and the charge then becomes self-propagating. All right? So this is from our understanding of the electromagnetic field. All right? So we have a good understanding of this. Now, how is our understanding wrong and consistent with ether theory? And be very specific.
It's not. It's used currently today in physics. Both of them. Both space-time and ether theory.
Wah, wah. Our survey says...
Yes, and everybody out there, I did say magnetic charge. My bad. That was just me messing up. I'm sorry.
I didn't catch it. I understand what you were on about.
You understand what I was saying? Yeah, they do too. They're just giving me a hard time.
It would be the main three things, which was Paul Dirac's work, was the absorption, the emission or transmission of particles through certain materials. And that's exactly what he discovered. If you fire, and that's what Carl Anderson discovered, if you fire an electron at lead, I think it was, out the other side came a positron. And as I understand it, let's say, is that the spin of an electron, the spin of an electron generates a magnetic field which is greater than its own mass and its own spin, angular momentum, can cater for. So there is additional energy drawn in from this medium, and the medium is the quantum foam.
Quantum foam is not the same
you
as
would
vertical
definitely
particles. You realize that?
Yeah, you definitely have to repeat that word salad for me, because I mean I kind of understand what you're saying. I kind of understand what you're saying.
Gleam, please do me a favor. Define quantum foam.
But that's the thing though. That's the thing. Hold on, Gleam. So like when I try to explain something to you, what I try to do is I try to explain it in the way that I understand it, not as I've read it before, but the way I understand it. Okay. So I don't try to speak. I try not to speak on things I don't understand. Even if you brought up something, I would be more honest and say, hey, I don't understand. Let me look into that and I can let you know at a future date or whatever. But for the most part, most of what you brought up today, I understand. Okay. So when I ask you to explain it and be very specific, I mean, work the mechanism out for me. Explain it in a way that I, who have a basic understanding of physics, could say, okay, I understand that. There's no inconsistencies with that explanation. When you just say stuff like, you know, I like I said, I would need to hear your word salad again to be able to really break it down. But but try to explain it as if I'm a 5-year-old. Okay, and what I'll do is I'll pick it up from there.
The only way I can is Einstein removed the ether. I agree with you. He did not need it. Yeah, it's a conceptual change. Did not do any different shit. Now we found that there is a medium, and we call this virtual particles, which are the antiparticles of real particles.
No, they're not.
Wait, hold on.
Ow.
Sorry, farmer.
Ow.
Oh, sorry.
Whoa. I'm going back to bed.
Oh, we've
Christ
already
on this.
we got to the first bit, so where he mucked up there. Now he's confused about that bit. Now I just need one more section to get through, just the ending part, how it finishes. So I've just got to find where, I don't know where it finished because I didn't actually watch this, so it has to end somewhere. I don't think he does any more presenting. I think he's just going to argue there.
Oh God, I was going to catch up and watch yesterday, but if it's over 3.5 hours of Gleam doing that, I'm not sure I can survive it.
No, I think you're going to just have to put up with this edited version.
Okay.
Catch the last went for 356.
What?
40, 30.
It's Gleam or Coriolis. What sort of choice is that?
We'll get 20, 10, 15 minutes. See if I can work it out. Try to work your math out here. 40, 40, 38, 39, 40. That should be enough. Yeah, stop there, will you? About there. Okay.
I think that message meant to say "I love you, Team Skeptic," and that's what it came out as because.
Yeah, they're reading there.
Just because.
Yeah.
FTFE for $5, £5. I'm Team Skeptic. Here, I'll say it right. I'm Team Skeptic in my VR Twinkie outfit, and I told Where's Wally that I was dedicating tonight's destruction to you and him and Ruhif for all that work you guys put in.
Goes back to his citations by the look of it.
I'm coming here from you keep on taking it to the whole proportion of saying it completely invalidates anything you say, and I'm saying it's equal in science to actually think of it as there is an ether. So why are people in 2020 writing papers on Einstein ether theory?
Because Einstein ether theory isn't the same as luminiferous ether.
Are you sure?
They're not the same thing. Yes, they're not the same thing.
Yes.
Okay, should we load up?
Oh,
yeah.
God.
What I'm picking up on is that Einstein had his space-time theory, but he didn't mention the word ether in it. And Gleam's trying to say that it's the same.
Up Einstein ether theory wiki now, and it says there blatantly, we're using Einstein's maths, but we're going to assume that there is actually an ether there this time.
Einstein's new ether is space-time.
It's called Einstein-ether theory. It was in 2004.
Yeah, and it's about space-time.
Oh, he might be talking. You said 2004.
Yeah, that's when it was.
Einstein wasn't alive.
Yeah,
in
Einstein
2004.
has been dead for a long time.
Oh my God!
So
yeah, you know the physics lives on after Einstein. You idiots.
Yeah, but it's not really some of the Einstein.
Load it up. Just load it up and stop being stubborn little babies. Picking your toys out your pram. Einstein ether theory.
I'm still waiting for you to answer one of my questions.
I think Gleam. I think I see a problem with Gleam. Would you say that Gleam has a problem with context?
Yes.
With a lot of what he's reading?
Do you know, I just typed in Einstein ether theory, and it takes me straight to the wiki page. And it says it's a general covariant modification of general relativity.
Right.
It's got nothing to do with the old-fashioned concept of ether. Nothing at all. It's as simple as that. And this is the whole problem with Gleam. He wants there to be ether. Like a lot of them, they want there to be ether out in space.
And what would that help them with anything else in their narrative?
Well, that would make all the a lot of the things that we know and understand wrong. They want us to be wrong. I think. I don't know. I'm not a flat earther, so I can't wrap my head around the whole concept of pretending that the Earth is flat and space is fake.
Well, I think they were just running short of things to be wrong about that day, so they decided.
Yeah, because Gleam has been wrong about an awful lot of things. So
I have listened to virtually nothing Gleam has had to say ever since he assured me that the tangent function will only work with radians.
Oh yes, that's a classic moment.
Mm-hmm.
Mm.
But Gleam's a mathematics expert because of his prowess with Excel spreadsheets.
Yes.
Oh, is he? Okay.
That's where he knows it. He knows all of his math.
Oh yeah.
Learned it all from Excel.
And where did he get his PhD from?
I don't have any idea.
I've got that T went down the wrong.
Well,
PhD.
Well, when you say PhD in terms of with reference to Gleam, I think it actually stands for pubic hairdo.
Yeah, I'll pay that one.
This is the guy who left school with no qualifications.
I'll pay
of
that.
course.
I think we're getting the drift of what's going on here with that guy. There we go.
Yeah, he's a flipping idiot.
Yep.
Hey, Farmer, do you want to be on top? Look, I can put you up top, see?
That's very kind of you.
Hey, I'll put you down there, sorry. Unless you want to swap places with Sheep, you're John.
Mate, wherever you want to put me, I'm not bothered.
That's a new trick I didn't realise I could do with Zoom.
What? To actually move them around?
Yeah, I can move them around. I haven't figured out anything else yet, but that's one of the things I figured out.
Yeah, one thing at a time. No rush. You know.
Okay. Do you want to get straight into the next one?
What's the next one?
The next one is Jose's chat. And we're going to
what the one I was rescued from yesterday.
Yeah? Okay. I'm
when Pip sent me a message saying I'm going live. Yep, righto.
Oh, okay. Oh, I didn't know that. So, because I got the tail end of Pip's stream.
Yeah.
When I got home this morning.
Well, I think it was quite an impromptu thing she was doing, and I think I was just spending all my time laughing at whatever Brian Leakey was saying because he hates it when I laugh at him. So, and I did tell him, look, you keep saying funny things, I'm going to keep laughing at you.
So has anything happened in the first half or the second half?
The first 80 minutes, nothing really happened. It was very quiet and relaxed, and we were just sort of, talking nonsense. I think it was about 80 minutes in, give or take, if I remember rightly, when Brian turned up, and then yes, the roller coaster ride started.
Okay, well that's 140.
But apparently Stingray did come in later on and have a bit of a argy-bargy with him. But I missed all that because I was in Pip stream by then.
Okay. We'll do a bit here in the middle area for a few minutes, and then we'll do a jump down towards there. So you said what's 80 minutes? That's an hour and 40 minutes.
It's an hour and 20. So
hour and 20 minutes. Sorry.
It was somewhere around. Oh, hello, Cat. It was somewhere around about the 80-minute mark, give or take a bit. When
can you see his little icon pop up anywhere there? I'm not sure.
You're not sharing it.
Oh, I'm not sharing.
So I can't. I can't see it anyway.
Sorry.
That's all right.
Okay, I'll do the transition thing too, so that way they see what's out there. Alan says to use the transition thing, so. Okay, you said hour and 10-ish, 20. I can't see it, it's so small on my screen.
There he is. There's Brian's.
Oh, okay.
Yeah, that's Brian's.
So after that,
icon avatar
come
thing.
Back on here.
No, Cat. That really isn't the best place to sit. No, but
it looks like about 20, 25. We'll go 25. Okay.
Ours.
Well, if it's a fat man, he probably has got a huge arse. So who knows?
Oh, it's the fat man, not fat man. Oh, okay.
Yeah, fat man.
But
it's all one word, fat man.
Yeah, FATMAN, like Batman, but with fat.
Because, of course, Santa Claus is the jolly fat man, isn't he? In popular depiction, so...
Yeah. That's actually he mentioned that. He said, like, you think I'm here because I'm fat and jolly? He mentioned that in the trailer.
Mel Gibson's particularly good at doing that sort of role. That's going to be what... It's not going to be any in between the other.
in fisticuffs.
Yes, Brian Leakey in the house. Let's do it. Welcome, everybody. Hey, I see a very low number of likes, man. 69. 69 is a beautiful number. 37 likes, 5 dislikes. Please, let's do it. We are currently joined by Big Blue, Brian Leakey, Chris F. Jackson, Farmers Boy, Howard Moore, and Leal is here. I'm focused. I'm having a smoke. I'm awake. Brian, this is going to be fresh start of the show. Do you want to... you got any route that you want us to go and explore today?
Yeah, I just wanted to complain about something. I got beautiful weather. I got time off to go to my spot. It's almost a mile to do the line test, and I can't get a hold of nobody.
Yeah.
And my youngest son ain't even here. I'm like, oh my God.
That sucks.
You just
nuts,
can't
man.
get the staff, can you? Hey?
Dude, I'm not even trying to do the convincing test. I'm just trying to do the the second preliminary to or not.
What are
y'all
you?
seen the line off the ground?
What are you, Brian?
600 yards.
Is that static coming from him?
Yes, Brian really overloads his mic. I presume he's using his phone. I think he's always using his phone, and it does get quite painful. Because and of course, Brian being Brian, the more agitated he gets, the louder he shouts. And I was having to keep turning the volume down on my headphones because it was getting painful to listen to.
Yeah, I might have to turn it down myself.
Yeah,
that's
but
terrible.
that is Brian, and I did sort of put in the side chat. Yeah, everybody type F for Brian's microphone.
Yeah, nothing happened.
Because he can't help himself. He just shouts.
I wonder Jose didn't pull him up on it.
I think even Jose did at one point ask him to
move
the mic away or something because it's like he's shouting into his phone. I think.
East of me or south?
Yeah,
I'm in the
east.
Tampa Bay.
I'm a little bit northeast.
Okay. Because I got a
probably about
shit
200
lot of
miles.
rain about an hour ago. I mean, like heavy rain, a little bit.
Oh,
here.
yeah, it did. It pissed
Now
me.
it's getting cleared up. There's still a big cloud, but it's moving, so I see
about to do
the
a
clear
jump.
sky.
Yeah, sorry. Go ahead, Lael. Sorry, mate.
I was going to say, so my question to you, Brian, is when it rains, is there metal in the sky?
Oh my God, you dumb down these conversations to unspeakable.
No, you said it takes metal to make water. I'm asking you a question about that.
No, to make the gases. Yeah, maybe I didn't explain myself good. To turn the water into the gases, you have to have all three. You have to have the water, you have to have the salt, or I'll just call it salt for simplicity's sake, and you have to have the metal. You have to have all three. And in every case, the metal corrodes and breaks down. And I just gave you a simple case of where it's easy to turn metal into that same gas that is flammable and floats. And like almost any chemical reaction with metal creates it. So how can we really prove? Their point is we can't 100% prove it's the water turning into the gas because the metal does the same shit when you put it in, muriatic acid. Certain ones you could put in even vinegar. You could put certain things in vinegar and create it. And you could put it in sulfuric acid, nitric acid. It all breaks down into that same flammable, lighter than air gas. So
Yeah,
they got a
I
good
could say-
point, man.
So Brian, I've worked on some systems where you have 48 batteries made up of quite large 2-volt cells, and you can replenish these cells with DI water, and basically they have a lifetime span. If they're continually being discharged and charged automatically, that charging points these robots, and what'll happen
I got
after a
questions
period?
for you, man.
Hang
I
on a
got
sec,
questions for you, man, because you know what you're talking about way more than I do.
Right.
Let
Okay.
me-
So
let
let me
me
just
jump
give you
in.
this. Let me just give you this case in point. Right now,
Okay.
after 3 years, if the battery cells aren't serviced properly and they're allowed to run slightly dry and then they're topped up again, Now, ideally, what you should be doing is topping them up with acid, but you need a hydrometer.
Yeah, but all
to
the
actually
water,
test.
all the water sulfates, though, right?
Right. Okay. So when you cannot use the cell anymore, when it dissipates its charge very quickly, it's because the cell has died because of the plates are worn, and what it gives off is a very accurate smell of gas.
You could also conflate that with there's no way to. I mean, they could slow down the dendrites, but they're gonna ground out eventually, slowly but surely. They're gonna ground out. But yeah, the lead, like you're talking about, and comparable to lead acid batteries, like it's crazy how the lead just dissipates, and you have like a bunch of rusty, almost non-existent lead still struggling to make a current. So yeah, it's hard to argue what you're saying. But I got a question. You're talking about DI water. Wouldn't rainwater be just as good?
Oh, that's a good question. Rainwater, well, it depends if there's any iron.
Did he say rusty lead? Is that what he said?
He did.
Yeah, that's what he said. Rusty lead.
Rusty lead.
At the start of that conversation, he was talking about turning water.
Electrolysis,
Yeah, through with electrolysis, but turning water into H2O. Well, we kept trying to tell him that that's what water is. That's all
water into H2O.
Yes,
that's actually pretty easy.
Well, yeah, but it got to the point where I don't think any of us could understand what he was talking about. I couldn't. Chris couldn't. We were all sort of like, what are you actually saying? And I think he was, for quite a while, he was conflating electrolysis with evaporation. And then when we pointed out the differences between that, he was just, yeah, what are you, stupid? You know, it's like, no, that was the mistake you was making.
Yeah, but
it was very difficult to follow the point he was trying to make, if he was trying to make one.
He was trying to throw in metal when it breaks down as well as the water and the... I was trying to figure out, was that a comparison or a... I don't know if that was a comparison.
I never did quite figure out what his point was.
The poor fool literally thinks that if you take, for instance, aluminum and pour some hydrochloric acid on it, you turn the aluminum into hydrogen. He is so backward and so non-knowledgeable when it comes to anything to do with any sort of science and chemistry included, that he cannot understand that reaction is freeing the hydrogen from the hydrochloric acid.
Yes.
Good Lord.
But at the same time, he's telling all us that we're all morons and idiots, and that we should free our minds, and we're indoctrinated. And
Glober Mom is right that water is dihydrogen monoxide. You betcha.
Yep. Nasty stuff, that dihydrogen monoxide.
That's right.
So rainwater, so in the spring would be like the only time not to use rainwater. And from what you're saying, that's what I get.
Rainwater? There's nothing wrong with rainwater.
I'm always trying to think outside the box, man.
I'm just wondering something though. When the sun, which creates heat, evaporates water from the ocean, there's no metal in the ocean.
No.
How the heck are in a vapor? Water vapor is a gas. So the sun is turning, the heat of the sun is evaporating water into vapor, which is a gas, and it's not taking metal to do so.
Correct.
So what happens to the hydrogen, Lale? Does it get left behind in the salt? That's
what salt?
Because the water vapor is not flammable, brother. Water vapor is not flammable at all. In fact, it's the opposite of flammable. I mean, in a sense. And what happens to that? So what happens to the hydrogen? I mean, does it just evaporate in oxygen? It's a good question, bro.
It takes metal to...
What's the flammability got to do with evaporation?
I have no idea.
That's completely wrong.
I think by that point I'd pretty much given up because I was just I couldn't make any sense of what he was talking.
Okay, so we've got that's two things I've picked up on.
Make water. It does not.
When you evaporate water, you get the oxygen, but you don't get the water. I mean, you don't get the hydrogen that's flammable, Lale. You're feeding into my point, bud.
The sun evaporates water into gas. doesn't take metal. Then clouds get heavy enough and form rain droplets,
Bro.
and rain falls from it, and that doesn't take metal either.
Not even trying to argue with you. Listen to what you're saying, brother. Okay, if the water evaporates gas into H2O, okay, when I do the electrolysis and I evaporate the gas into HHO, it's flammable. Okay, it's lighter than air, so yeah, it would go up and make a cloud, but it's also flammable. Okay, with the electrolysis. Now, why isn't evaporated air? What happens to my question is what happens to the hydrogen? Okay, that would make it flammable. If the water
Was that a quote? Was that another quote we can take? When water evaporates, it becomes H2O.
Yeah, that's what I meant.
Yeah.
That's what I said earlier on. And you're just sort of like, did he just say that?
He just said that. I thought, what? Okay. Oh, it's another classic quote.
Oh Lord!
I've got a classic quote from him before about something. It's around somewhere.
Hold on, let me finish. If the water
Oh, when the Earth spins at what the Earth's radius is whatever miles per hour it is.
Yeah.
Yeah, that's the one. Something like that.
evaporates into HHO gas, okay, or H2O, if the water
HHO.
evaporates
What?
into a gas, why isn't it
He doesn't
flammable?
know. He
'Cause when I
doesn't
do
know
the
his chemical
electrolysis-
symbol.
H2O.
Why can't you do it without salt?
You can. You can evaporate
No, you can't.
pure water with heat.
It's called the sun does it all
No,
the
why
time.
can't you perform electrolysis without
Okay.
Got to do
Okay,
with
gents.
it.
Electrolysis
alkaline
isn't
origin.
evaporation.
All right, gents. Just a quick one back to
Oh,
Pete and Pete.
Christ.
They distilled water.
He's talking about two different processes of something.
I know.
Think about the friggin' word, Brian.
Yeah.
What does it start with? What?
What?
Yes.
Would you suppose you might be missing something here? Like
I think he is
electricity,
missing-
maybe?
Yeah, he's missing something, all right.
Yeah.
Oh, Jesus.
I'm going to run out of fingers here soon with all the stupid things, the statements he's making.
All right, through certain processes. You want to watch that video? It's very good. They got the purest of air. They had a video saying air is water and water is air. So I'd recommend
It kind of seems like that.
Yeah, but it's not. Air is not water.
Well,
Water is
you
not
want to
air.
have a look at their experiment, Farmers Board,
No,
because
I-
they
I-
superheated it.
In the air, there
I
are
really don't, because water doesn't contain nitrogen. Water doesn't contain carbon dioxide.
Does not
Water
compute. Does not
hydrogen
compute.
and oxygen.
So address the fair
Does not
point.
compute.
Brian, I'm sorry, but water is H2O. It's hydrogen and oxygen.
Okay,
and
so when it
nothing else.
evaporates into a gas,
it's still
why
H2O.
is it not flammable?
Because it's still H2O. It's just in a
H2O.
gaseous state, not a liquid state.
Okay, there you go, Lale. So quit bringing up evaporation. It has nothing to do with electrolysis. Nothing. So don't bring it up.
Oh, that just went complete. That just went complete circle. That did.
I know.
That's complete circle. Okay.
Oh my God. This is why I keep laughing at him, and this is what winds him up, because he hates it when I keep laughing at him. And it's like, Brian, stop saying silly things and I'll stop laughing at you.
I wouldn't have been able to stop myself laughing after I heard that.
Oh, it really winds him up. He keeps having a go at me. Oh, there's Farmer's Boy again, chuckling in the background. I was like, yeah, you keep saying funny things, so I keep laughing.
Why are you laughing?
Yeah.
If
Oh,
I
and
was on
he-
the panel, I would have said to you, I said, "Hey, farmers, is something funny?"
Well, he thinks that I'm patronising and condescending and all the rest of it because I'm laughing at him. I'm laughing at him because he keeps saying funny things
Yeah.
like that, you know.
Well, a comedian on stage, when he says something and you laugh, he doesn't look at you and go, "What? You laughing at that?"
Well, this is the problem. Brian is being very, very serious.
Oh,
He is.
okay. Oh, he's got his
In all
serious
the
face
crap
on.
that he spews,
Sorry.
he genuinely believes what he says. And that just makes it even funnier.
Oops, sorry. Yeah. Okay. And he's got his serious voice.
We know you know how serious he is because how loud he's shouting at you.
We'll keep going for a little bit longer. because I'm running.
Oh, this is great.
I'm up to. I'm going to have to take my shoes and socks off to start counting all the stupid things.
Oh, you wait till you get some relative density.
You mean I'm going to run out of digits altogether in a sec?
Yeah, you might need to go. You might need to go and grab the wife and borrow her
well,
fingers
she just
as well.
came home, so that was great timing.
Oh, there you go then.
Tell her to go and take her shoes off, and she go, "What? Why?"
I need your fingers and toes. Sorry.
She'll give me a dumb look.
Yeah.
Oh, out of this.
Right.
Or not out of this, but into this. How about that?
You was the one who was conflating electrolysis with evaporation. They are not the same process.
Well, Leo compared it to a cloud, okay? Leo compared it to a cloud, and why don't we? He ain't got his cloud shoes on today, okay? I'm just trying to put him. I'm trying to get Leo to wear his cloud shoes. It ain't got nothing to do with what we're talking about.
I only brought up a cloud because it turns into clouds of water droplets.
Well, a cloud is water droplets. It's just that those droplets are small enough that they remain in the air. And rainwater isn't that pure, because do you know what each drop of water forms around?
Oh, yeah, they are pure.
No,
yeah, I know, but that speck of dirt doesn't compute because look, I've got a counter. I've got a parts per million counter, and rainwater is
oh, that's a relative density indicator.
Yeah, he's been learning.
Oh, here we go. We're getting into relative density now, and I do kind of get a bit irate at him.
As long as he doesn't bring an egg into it, we'll be right.
Oh dear.
Distilled water I've bought so far, and any spring water, barely. I'll show you on camera. Everything I say, I gotta show on freaking camera, dude. I got a parts per million counter, and I got a bucket of rainwater. It rained last night. Want me to show you what it is? Guess what it is? Parts per million.
It's loud.
Could everybody press F for his microphone?
Right here.
Sorry, man.
Yeah.
Hey, Farmer, I think what he's getting confused with is that while it is true the air has oxygen and nitrogen in it, helium, that water itself is a combination of those two. It's not air.
Correct.
Because
Well,
I
you
can't
don't
go
know.
I can't dive in the ocean and breathe the water.
Leo, you're just trying to hear yourself talk. You have no idea what we're even talking. Leo, what's a dendrite? What's a dendrite?
I am saying facts. The air that we breathe has multiple elements in it. One of those elements is hydrogen, one of them is oxygen. When you combine two hydrogens with one oxygen, you get water, which is in the ocean. And I cannot go into the ocean and breathe
You can't just combine
the air just fine.
You can't just take some hydrogen and stuff it together with oxygen. It takes other elements. Every time you have to have electrodes, positive and negative.
When evaporation happens,
that doesn't sound right. You can have different concentrations of oxygen in air. You can increase or decrease certain components. Don't they breathe different air when they go down diving to help with the bends or something?
Yeah.
Yes.
Substitute helium for and some witch's brew of gases, but it's heavy on the helium side for whatever reason. I'm not sure why that works, but.
Well, yeah, I can't remember exactly how it works, but it is to try and alleviate the problems with the nitrogen, isn't it? It's the nitrogen in your bloodstream, which is what causes the bends if you come up too fast. And I think what the hell does the helium replace? But that's what it's all to do. It's all to do with reducing the risks of getting the bends with the nitrogen bubbles in the bloodstream.
That's not how it works.
No, I'm not talking about water vapor, Blue. Please don't bring us back to water vapor. Please don't bring us back to temperature and water vapor. Please.
I'm just wondering what a raindrop has to do to become a raindrop if it takes other things.
I'm wondering why Brian mentioned dendrites, because that's to do with nerve cells.
No, that Yeah, but that is a universal term, though, man.
For what?
Dendrites. Okay, so you got to put the plates together, and the more you squeeze the plates, he was talking about a battery. The more you squeeze the plates together, the more that you get your full potential of the batteries. But the problem is, no matter what material you use, the dendrites will get through them, and then start grounding out. And
Does he know what dendrites are?
Well, I have to admit, I do confess that my understanding of the word dendrites had nothing to do with batteries.
Okay.
I didn't think it did either. I have no idea what he's going on about.
But whilst he was saying that, I did have another look at it, and yes, it is also a term, confusingly enough, used in batteries.
So what's it to do with?
Hang on, I'm having another look because I can't remember.
Okay.
They are tiny, rigid tree-like structures that can grow inside a lithium battery. Their needle-like projections are called whiskers. Dendrites and whiskers are holding back the widespread use of lithium metal batteries, which have higher energy density than their commonly used lithium-ion counterparts. So, Brian, I think follows some very weird and bizarre YouTube channels, and I think that's where he gets a lot of his ideas from. But I think this whole dendrites in batteries is actually a thing. I was quite surprised.
In lithium batteries, not lead acid batteries.
Correct. So he's picked up something somewhere that's right, but he's misapplying it.
Right. Okay.
And I got news for Brian. The more you squeeze the plates together in a lead acid battery, the quicker you're going to blow your ass up.
Yep. Because that goes against how a lead acid battery works, doesn't it?
Yeah, they got gaps between the plates.
Kind of better if you don't short those things out.
Yes.
Sulfating even faster. I mean,
dendrites are branched protoplasmic extensions of the nerve cell that propagate the electrochemical stimulation received from other neural cells to the cell body. What's that got to do with a battery?
Because the dendrites are formed, okay, like let's just say like a zinc manganese dioxide battery, okay. The dendrites, they can be microscopic, okay, and but they're going to form and they're going to get through any like separator that you use, and they're going to eventually branch out and ground the positive with the negative on a small scale. So they're going to start grounding out the battery. That's why every battery dies slowly, because it starts grounding out slowly but surely on a super small level. But over a few years, the dendrites make it through the separator that separates the positive and the negative cells, and it just starts accumulating. And that's pretty much the main reason to me why the batteries slow. That's one of the main, constituents of why the batteries lose their charge, is because of the dendrites. That's a major problem. But that wasn't like
what's this got to do with water?
Yeah, that wasn't the main topic.
Yeah. That's kind of what I was saying. Like, liquid H2O and vapor H2O are water.
Yes, they're both H2O.
Okay, gents, can I just?
But are they H2O though?
Brian, 1 second. Let's get to Chris.
Oh, okay. I just want to just bring this back to basics, if I may, in all respect, gentlemen. So, if I ask a question that, how, if I had a gas, how do I turn that gas into a liquid? It's not a trick question. It's what we do. We do it all the time. We
don't you either freeze it or you heat it or whatever, something like that.
Yeah, well, you can pressurize it or cool it off.
We compress it.
You heat it up.
Compress it.
You burn it.
No.
We compress it. If you compress it enough, it'll turn into a liquid. That's how they store liquid gas, right? They get gas, they compress it. We have it every day in our home with refrigeration.
You can't just put it under pressure, though. And
let's hear Brian. Let's hear. Chris is almost there. FE is almost finishing. Let's hear his statement.
How you doing, Chris?
So I can. Hey, Brian. Yeah, so we can compress it. So if I had a hydrogen gas and oxygen gas, and I compress them both, right? The question I'm asking is that what sort of compression rates would I have to do the two individual gases to get them to actually liquefy? And the question is, what temperatures would they actually liquefy at? And they're both different. So if I join those two together, would I create water? And you'd have to say yes, because water is H2O, right?
I'd like to see an example of that, man. Yeah,
Right.
you would have to, but you don't.
Doesn't exist, does it? You can't mix
No,
the
it
two.
doesn't. Exactly. And but you could say that the act of of compressing it, compression, but that would mean you could just take the gases and just put them at a certain compression and then that's it. But that's not the case. It's the act of the compressing it. You'd have to compress the shit out of it and keep it compressing, depending on what compression it even started at, man.
Yeah,
It's
so
tricky, man.
liquid hydrogen is a lot lower in temperature than liquid oxygen.
Yep.
And I did ask, actually, on the basis we're talking about the cell structures, as Farmer's Boy was saying, I asked down at the aquarium in Plymouth, they've got one of the biggest tanks in Europe, I think. Anyway, I got talking to a marine biologist down there who's a PhD doctorate, and he was doing some research with some marine animals. I just happened to cross his path, a friend of a friend, and I was got chatting to this guy, and I said about gills and about breathing water, and talking about the gills, and I asked him, actually, I said, how do gills work? And he actually said to me, well, as the water's flowing through, the blood stream's going through, it diffuses into the blood. And I said to him, but that's the process, but how does it do it? And he said, he told me what the process was, but not how it was done. I said, okay, you're not telling me the process. Is the process chemical or electrical? And he couldn't tell me. He couldn't answer me the question.
All right, let me see. Brian is showing some kind of a device there. What you got, Brian? You got it on mute.
It's a parts per million counter. Now look at this water. It's rusty. This rainwater's been in this barrel. I've washed my hands off after messing with batteries and shit. And it's rusty looking and all that. I don't know if you can see this. See that water?
Yeah, that's mosquito.
Yeah,
So
now
it's
watch the
keystone.
parts per million. Hopefully, let's see if you can see it. It's only 5 parts per. Nope. Okay, 21 parts per million, man.
Of what?
20, dropping it.
Of
No,
what?
10. 10. It's going from
Of
10
what?
to 20 parts per million of particulates that dissolve in the water. But here, look, this is clean water. Here's some clean
what
water. It's not that clean, but look.
What
So you got
particulates?
4 parts per million.
They have to
4
be the
parts.
right particulates for it to work.
Dude, there's a old spearhead at the bottom.
So what? He's not mentioning what parts in the million. Which parts is he measuring for? You don't know what
These
particulates.
particular meters, what it's basically doing is it's measuring the electrical resistance of what's in the water, and it has to be the right stuff. That's why a certain Mr. Riley's experiment with an egg, that's why he put salt in the water.
Yeah.
If he'd put sugar in the water or he'd put anything else in the water, it wouldn't have worked. You had to put salt in the water to change the, I think it's the resistance, the electrical resistance. I mean, the whole joke of that thing was what he should have been using was a hydrometer.
Yeah.
To measure the density of the water.
That's right. Which is what I tried to argue with Riley about one time over on Nathan Oakley's channel.
Yeah, he used completely the wrong instrument for the experiment he was doing, and even he didn't really understand what his little parts per million counter was doing.
I wanted to explain to Riley how a hydrometer works, and he said, "Come on, come in." And I said, "Oh, sorry, I haven't got a microphone. I didn't have a microphone."
He wouldn't have liked your explanation because it's relative density.
Yeah. Oh well, I got out of that one.
Bottom of this, it's been here for, I didn't wash my hands in this one, and it's been here for about, I don't know, at least a month. And I use water out of it, but every time it rains, it overfills because the rain's been surpassing my water use back here. But 4 parts per million, man, that's That I mean, just best spring water is a couple parts per million, and
I don't know how true this is, but I was using it there one time to top up my batteries. There used to be a ColourBond roof and gutter system and plastic pipe, and I collect the water out of it when it rained, and I thought in my way of thinking, well, because it's touched paint and nothing metallic was in the system, it was all plastic and ColourBond, there'd be less particulates, metal particulates, like if it touched iron, like a normal iron roof, or some other type of system, metal, just to top up my battery, just with a little bit of water, because it needed some water. In my thinking, the water was a bit more distilled in that context from the rain, it being rainwater. As long as it wasn't touching anything to put any more metal particulates in it or whatever, like the stuff that's already in water out of your tap or whatever, straight from the dam or whatever it is.
Yeah, I suppose.
Well, just a way I was thinking of.
Yeah, I can see that. He's like,
and that water's been in that barrel for a month, man. I'm just saying.
This is the problem with globe deniers. They get a device like this, put it in water, and say 5 parts per million. But what does that mean to an average person?
It's what's dissolved. It's the stuff that's dissolved in the water, brother.
5 parts per million of what?
Yeah. Okay. So another measurement you could make for water is the resistivity, which is measured in Siemens or microsiemens. So that would give an indication of how pure the water was. So systems that I've used, I've got to have water that's actually has a microsiemen reading of infinity. Anything that's in that water, I cannot use. So, one gauge of measurement that I would recognise was forget the parts per million. I know that 4 parts per million is quite very low, so that water would be quite resistive. And if you read it with a microsiemens meter, then it would be.
There's so many questions in the chat. So many questions in the chat.
Yeah. To the layman, that's the stuff that dissolves in the water. But to what he's talking about, that'd be a little bit high. But that is low enough to where you cannot conduct any electricity through
Exactly, mate. So if I were to put that resistivity meter into that water, it would be heading towards infinity. So that's what I was trying to get.
You could not freeze it in the ice either. You could not freeze that in the ice.
So, Chris, would that be using reverse osmosis?
Sorry, I gotta go soon. But what you said made sense, Chris. Sort of, if I could understand what you were saying correctly, and Brian wasn't interrupting.
Somebody grumble?
Did he? What did he say? You could not freeze into ice. What?
Yeah, I missed that bit.
Pure water, I think.
What in the hell is he going on about?
I pass.
He said water, he would be hit.
Not freeze that in the ice.
So, Chris, would that be using reverse osmosis?
Oh, he's saying that the water
resistivity meter
he was mentioning.
Any electricity through
exactly, mate. So if I were to put that resistivity meter into that water, it would be heading towards infinity. So that's what I was trying to
You could not freeze it in the ice either. You could not freeze that in the ice.
So, Chris, would that be using reverse osmosis?
Sorry, farmers. I gotta go soon. But what you said made sense, Chris. Sort of, if I could understand what you were saying correctly, and Brian wasn't interrupting. But what you said made sense. But him just sticking that device in the water doesn't do anything. It just tells me 4 parts per million, but it doesn't tell me of what particulates. What is
dissolved particles per million.
I mean, it could be anything really. It's that any ions that are in there, you could put anything in there, and if it's just simple tap water, you can if he was to stick that into our tap water, it'd be measuring in the hundreds of ppm.
Yeah, mine's about.
What's that water they used? The Germans wanted to use hard water or soft water or something at one time.
Oh, that was hard.
Heavy water. Heavy water.
Oh, heavy water. Okay. I know pure water's something. I know we can't really drink it. Well, we can't live off it. Pure water. You'll die from dehydration or something, or whatever it is.
250. My average is about 250.
So you have a lot of organic material in the water, which would be able to conduct the electricity.
Well, it's dissolved. It's dissolved. In other words, if you stuck something super clean in there, Lil, that didn't dissolve in water, and you cleaned it in a clean room and stuck it in there, it would not change the parts per million. It's dissolved particulates, counted parts per million. In other words,
that, but particulates.
Well, what are you asking, brother?
Particulates of what?
Of substances that dissolve in water. Substances that dissolve in water. Like if I was to add salt, anything that dissolves in water, Lil, anything that dissolves in water would raise the parts per million, bro.
Particulates of what? It just said 4 parts per million. 4 parts per million of what particulate?
Any particulate that dissolves in water. Okay.
Right. What particulate was in that water then? That's what I'm asking. You're just saying an empty measurement, not telling me what you're actually.
Hold on, I put it under my microscope, dude. Let's see. You want me to put it under my microscope? We can see. I don't think it matters, dude. But I mean, if you want to do it, we can do it. Here live.
You're just making an empty measurement, not explaining what you're actually measuring for.
My point was, Lil. You missed the point. The point was.
As opposed to Chris, he explained a different type of measurement.
Okay, great.
Show you actually what you were measuring for, where you just stuck something in and said 4 parts per million. Well, great.
Well, my point was that it's not conductive. You cannot break it down. You cannot break it down into hydrogen and oxygen as is. Not the water that falls out the sky. You cannot change it into hydrogen and oxygen with electricity. Okay, that was my point. And
yeah, I was just trying to quantify it in terms of a known measurement that if somebody gave me a glass of water, it was 4 parts per million. I'd know straight away what it would what it's telling me, that the water is pretty much pure. And is that from experience or from what I've come to know? If you've not been involved with any time of these measurements, then you wouldn't have a clue what it means. It's not so much what the matter is in the water, but it's the fact that the water has a measurement of ions in it, which are at 4 parts per million.
That's what it's measuring. If you don't put something in there that helps conduct the electricity, then it won't give you a reading. Which is why if you dump sand in there, it wouldn't have the same effect.
All I want to know is what in the hell Brian uses that bucket of water for.
Hey, wait. Let's dump some sand in it. I think he's right.
I think he's right. FE for explaining that, because that actually makes sense now of what you're measuring.
That's why Riley put salt in his
4
water.
parts per million. That means nothing to me.
Yes. That's why Mr. Riley and his famous egg experiment, he put salt in the water because it creates an electrical resistance.
Farmer's boy,
That's
you can say that all you want, bud. You can say that all you want, but everybody knows salt water is more buoyant than fresh water, and so is cold water. Cold water is more buoyant.
Let's talk about gravity.
Water, okay.
There you go.
Wait, hold on. I'm gonna put some sand in it. I think he's right. I got some clean sand. I was gonna put it in there just to show everybody, but shit, I gotta charge my phone for a minute. But
that's why he
right.
used.
You put clean sand in there, and it won't change shit.
Of course, what he should have used was a hydrometer to measure the
temperature, bro.
Density of the water.
We've done the same thing with temperature. Just get the water super, super cold.
I didn't mention temperature at all. Riley's egg experiment should not have been done with that meter. It should have been done with a hydrometer.
You're desperate. Relative density is a force.
No, it's not. Relative density is
it
the
is.
ratio.
Yeah, it's called specific
Dude,
gravity.
you can stick your head in the sand all you want, bud. Relative density, we can move shit. We can float a hot air balloon. We can't move shit with gravity, bud, but we can move stuff with relative density. We can float in a hot air balloon. We can float an egg. There's plenty we can do to show that relative density is a force and gravity is not. Deal with it. This is blue shoot. This is where blue comes in usually.
Relative density is a unitless ratio. It has no force.
Relative density is reality.
No.
Gravity is not.
A specific type of gravity. It's a ratio
It's a unitless ratio. You're comparing the density
John
of material
Bernard's. John Bernard's.
Unitless in your math.
another
Unitless
material.
in your math, man. Okay? It might be unitless in your math, but in reality, we can move stuff with relative density.
No,
okay?
you can't.
The only thing we can move with gravity is if we.
Does he go into the density and buoyancy now for a while with gravity? By the sound of it,
I can't remember. It was all getting very annoying.
Okay, we'll do a jump. Jose's doing a thing, and we'll come back to that. There we go. See what he's onto him now.
Then you have to cool it down. You have to cool it down, and you have to figure out the math. Is if you drench it under 5 degrees Celsius water when it's drying, okay? And then let's say you add nickel. Wait, then you add nickel, right? So my point is for every factor that you are making that steel, it doesn't matter, man. For every factor that you're making that steel, you have to another farmer's boy. But you have to redo the math.
I've forgotten about Adam. He came in and did a pretty good job of winding Brian up.
Oh, okay. Is that Adam laughing? That wasn't you.
Yeah, that was Adam. I was just sitting back.
Yeah, it
and
didn't
enjoying
sound like your laugh. Yeah.
No, that weren't my laugh.
No.
But he doesn't. He really doesn't like people laughing at him.
For every factor, you have to redo the math, okay? So once we figure everything out, we do the math. But if another factor, okay, fine. Who cares?
Bro, no one did listen to the whole of your run.
Oh, he's gone.
Maybe he dropped. He pressed the. Yeah, I mean, the button has been switched for the app, so maybe he's got the new update where the mute button used to be where they hang up call, and they kind of flipped it. So yeah, maybe
or
he'll
his phone killed himself.
God. Or he got a phone call, or he fell, in the bucket.
He's finally overloaded.
No, but this just looked like he tried to get his message out, his rant, I would rather say, out, and then just leave.
Does he come back in?
He does, yes. And I think that's the point that I bailed out. When he came in was when I bailed out.
Okay.
So I don't know what happened after that.
Somebody's doing something here.
But I'm fairly certain Stingray came in at some point, but I couldn't tell you when.
Farmers.
Yeah.
It's called a sling psychometer.
That's yes, right. Thank you. Yeah, I was getting confused. I used to have one, but it might have got lost in sort of house moves and things because it's got the two. You get the wet bulb and the dry bulb temperature, don't you?
Exactly. Yeah, that's what it is. It's a thermometer with a thing on the end of it that you're measuring the evaporation of water.
That's it. It's got a wick on the end, and you have to wet the wick and then
sling it.
Wind this thing round like the old rattles they had at football games. Yeah. I used to have one. I suspect it's vanished, but I tried to keep hold of it just for sort of curiosity's sake rather than anything else. It's a long time since I've used one.
Yeah. Yeah, you get the wet bulb temperature and the dry bulb temperature, and then look it up on the psychometric chart. And
it
will give you the relative humidity.
That's it. That's a long time since I've done that.
Let's see what this presentation with the skylight is, and if that's nothing, we'll jump forward.
That looks like that's Beebles.
It is.
Okay. That's Beebles
cool.
stuff.
Past the buildings, you can't see the beach because the buildings are in the way, and the angle you got. But it's always changing. It's obviously optical, and going over that bridge really let me know that it changes constantly, man. But every now and then, when the air is real crystal clear, you can see the ocean way out there. And at the angle you got, it's got to be real clear for you to see the ocean. But the horizon, it changes. It changes in height, bro. It's always changing, bro. Good.
What does optical mean, Brian?
I would say it means it's not physical, maybe.
What?
I'd say not physical, like it changes, you know, like an optical illusion.
What you're saying? Okay, all right. That answers
I love
the
the
question.
subtitles.
But yeah, B-ball is always going to get that in Hawaii in the heat of the day. You know, at least give us some shots when during the winter on calm days, which I don't know how many you get on that side of the island. But
Brian, do you think if this continue getting repeated 20 times, 100 times, 1,000 times, maybe there's going to be one day that there's going to be the bottom of these buildings, half of this building is missing. Maybe we want to see this bottom half and some palm trees in the bottom, a little bit of
I bet my life.
Really?
I bet my life that it'll change with different temperatures, different clarity of the air, and different size waves. So many factors. I bet my life it'll change. It'll never be the same. Earth curve is changing constantly. Okay, if you want to look at it like that, that's no way.
Okay. If I don't remember wrong, I
like
think
that.
this building, yeah, we're missing like a bunch of floors in here, plus everything in the bottom. You know, do you think there's some days? Yeah, I mean, and I bet if people keep recording, I think he have some like boats and jet skis and stuff just cruising around here, like in the where the horizon appears to be. So if you say this is an optical thing, how is this water this high? And we're not getting a giant wave like a tsunami either to where the observer is or where the buildings are, because there cannot be just one big hump of a wave in between
right.
where I
It's
am
the same thing.
to the buildings that you say is
It's
a
the same
big
thing
wave.
as the very first presentation he made. He showed, but there was little white caps, and them little white caps on the very first presentation he made on your show, them white caps were blocking like a third of a building. Just little tiny white caps, maybe a foot and a half, but way off in the distance they were blocking, 50, 60 feet. Okay, it's perspective. You know this, man. Quit playing games, bub.
Perspective is this building was, if this was a flat surface from where I am to the end, and let's say the wave is 10 feet, it will only block 10 feet at the end, and 10 feet above that building will be visible 100% of the time in a flat surface, you know? Unless you're claiming there's a 100-foot wave in between me and the buildings, that will block 100 feet in the building at the end if it was a flat surface.
Well, what if we took a 100-foot building and we put it 1,000 miles away? It'd be a speck.
Oh, no,
Then the white caps would not only block the building, they block the clouds above the building, but
let's say it's 100 miles away and we see a little bit, just 2 pixels, but still that 100-foot wave will only block 100 foot of the building. So it will still be visible above 100 foot. If there was a 100-foot wave.
You got to start with clouds, bro. You got to start with clouds. Everything around me right now, I'm outside, and it just looks like a big dome around me. The clouds that are, 5-6 miles away, they're dropping down and getting blocked behind the trees, okay? And them clouds are way higher than them trees, okay? And I know what you're saying about geometry, okay?
Alan says good morning, I'll be in a minute. Quick, let's all hide.
But when you get to that tiny little
you haven't seen us, right?
part where our vision gets cut off way in the distance, them white caps blocked a third of the buildings. Them 1-foot white caps that were under his viewer height, or damn near level with it, his 8-foot viewer height, them little tiny white caps that are at the end of our vision, okay, are all compressed, and they blocked a third of the building. And I mean, we all know that, whether the Earth is a flat or a globe, we know that something way off in the distance is very, very, very small and blocked by something, minute.
Thank you.
This level of stupidity, good Lord.
These cows.
Big shout out to people. Thank you for sharing that.
Those cows are far away.
My God.
I know. It really does get very difficult to listen to sometimes.
I want the bite off that show. Just that little bit where he says the cows are here and the cows are far away. Just that bit.
Brother, everybody got the idea over here in the chat. So everybody will do their own, that shouldn't be all visible.
Under our feet. I look at a kayak 4 miles off in the distance, it should be under my feet, right? I'm standing on the shore.
It is.
I know
It
that.
is, and you can measure this drop.
Right? No, come on. What do you, the kayak off of the distance looks above me, or at least
So
level
if you
with
got
me,
your
right?
head looking, if you got your head tilted, if you got a hump, you're gonna be looking up because your eyes are gonna be looking up. But if you are very proud and you got your head high, you gotta look low, right? But if you are like geometrically straight, it appears to be in your eye level, maybe a little above. But throw the measuring tool, throw a measuring device, and it will measure the drop. It will be always, because the ocean is under your feet. The boat is the bottom of the boat is always under your feet, always.
But you're always looking up at it. You're always looking up at it, the coastline. You're always looking out level. You're never looking down. But look, that's a good argument, though, man, as far as the vectors, because perspective seems to have a vector also. Like when he mentioned if you brought the metal from Japan, would it want to go back to Japan over its density? No, vector
What?
up and down, man.
What did he say?
I do miss that
If
too.
you bought the metal from Japan, would it want to go back to Japan because of the relative?
Also, like when he mentioned if you brought the metal from Japan, would it want to go back to Japan over its density? No, vector up and down, man.
That didn't make no sense at all, that did.
But,
I think that was
I
sort
can-
of like
yeah,
a cross between an item that's going to where it belongs if it falls, because like you drop a pen or whatever. Goes
Oh, this whole argument over why things fall because
Yeah.
they're going back to where they came from.
That's right, yeah. So
Yeah.
he's throwing the metal in, yeah. The metal's got to go back to Japan because that's where it came from.
You broke up there. Anybody? We got a few more guesses. Let me shout out everybody here. In the house, Adam L., Brian Leake, Howard Moore, John Bernards, Lori Letiaho, and Philosopher of Nonsense. Boom.
Boom. Oh.
Thoughts, questions, comments? Go ahead, guys. Take the floor. I'm enjoying the modelo. The modelo especial.
You know, hey, talk about gravity. Density is specific gravity. So, okay, you can call it gravity if you're talking about density.
I think we'll jump ahead a bit.
Really quick on that.
No, it's
Okay,
not
one
proof
more
of the shape of
jump.
the Earth.
That should be it.
I'm just trying to prove always caused by Earth curve.
I've got a question for you, Brian, if I can.
Go ahead, Stingray. Thank you. Welcome.
Is this when Dean come in and he was all sick and everything, and then he got going and hyped up, and he reckons he's in adrenaline
Must be.
kicked in, and then he felt
Yeah,
all right?
must be.
Yeah, this is what he told me.
Yeah, that's what he said last night, wasn't it?
He uses adrenaline to feel better.
Hello. Can you or any flat earther, since you're in this very, very small minority of people, I'm going to ask you I'm just going to ask you one question.
Hi, Alan.
Hiya. Good morning.
I had another problem.
Morning.
I had another problem with OBS again before the live stream.
You give me a situation where the rest of the planet doesn't expect to see Earth curve, where something that is in front of another object can be at the same level.
I'm still waiting for
any
you to get back
situation
with model.
Wait a minute, let me finish. Any situation where
Make a model.
if one object, no, let me finish, Brian. One object or one surface or one matter, I don't care what it is, something is in front of something else blocking it, but it not really be in front of it. I just want one example in reality, because in my reality and the rest of the planets, that is impossible. If it was flat, there we
Stingray,
go. Yo.
you sick? Are you okay,
I am
bud? You
actually.
sick?
I am actually.
Are you getting better or worse?
Medium. No, not
He
getting
may
any
feel
worse. Not getting any better at the moment.
He may feel better in a little while.
Stingray.
The answer is you're
whiskey.
presupposing planet. You're presupposing Earth curve. You're presupposing. Okay, if you would make that model, it's a simple little model where everything in the distance disappears at 0.02 degrees. It'll match reality. Okay, it might not match the ocean. Okay, on the Hawaii Ocean or the Florida Ocean, but it'll match the Chesapeake Bay. It'll match deserts. It'll match the salt flats. If you make everything disappear at 0.02 degrees, I'm still waiting on that model.
Right.
And,
Just 2 seconds, Brian. Let me answer that. So the issue with that is something that takes up 1 degree in our vision. We could divide 5 times and have each of those sections 1/5 of that 1 degree, as in 0.2 degrees. Or let's call it a 50th, 0.02 degrees. So we could divide 1 degree into 50 segments. Each one of those is less than 0.02 degrees. That does not make the object invisible. The arc seconds on whether something is visible based on perspective is based on the minimum and maximum height.
I gotta say it. Okay. Combine. Okay, then do it like this. If you don't understand that, so whatever is your ground, combine whatever is above.
You know what's going to come when you get somebody like Brain Leaky, say something to Dean, and then Dean's going to come back.
Of your ground when it hits a limiting angle of 0.02 degrees, okay, then combine it with the ground. If the ground is asphalt, so it's black and shiny from reflection, whatever, then whatever gets less degrees, then combine it with that shiny reflection. Pete's Mirrored Waterland, shout out to Pete Cherry.
Could you just stop a second, Terry? 0.02 degrees is only 1 minute and 12 seconds of arc. And I don't know why it's supposed to be a special value.
No.
I mean, there's nothing particularly special about 1 minute, 12 seconds.
Well, I think Pete
He's trying.
I think Brian Leakey said a number to start with.
Yeah, he's trying to go on about the Rayleigh criterion.
Huh. I answer that because I have actually no problem seeing stuff that is 1 minute of arc at times. So
no, you'll see 1 minute of arc, of course. Yeah.
You talking about as in degrees of a circle?
Well, yeah, but each degree is also subdivided into 60 minutes, and each minute is subdivided into 60 degrees. So there are 3,600 arc seconds in a degree.
Right.
So the issue, Brian.
You're going to do it with water, combine it with the blue water.
Yeah,
If you do it with ice,
listen
do
to
it
this,
with
Brian.
ice.
Okay. Listen to this, Brian.
Why don't you make a model like that, Stingray?
Hold on, Brian. Listen to that. Let me.
Because in geometry and reality, it's impossible and a waste of my fucking time. Now, I put it to you the following. If a ship goes away and the top of that ship is, let's say, 0.1 degree, clearly visible, arc seconds, yeah? Degrees. So 0.1 degree. Now, the bottom of it is also 0.1 degree because the top and the bottom are the same size. Vertically.
I'm not talking about 0.1 degree.
Wait, listen, let me finish. Now, that ship goes away. And
when you say 0.2, you're saying 2, you're saying 1/50th, it's 1/500th, bro. 0.1 is 100th.
Stop. A camera lens will allow me to zoom in and see very fine detail, a lot more than the 0.02 degrees of the human eye. So throw the human eye out. All you need to deal with is if I can see the top 30 meters of a ship, my God, I should be able to see the bottom 30 as well. And they should take up the same vertical space in my optic. The problem is there's ocean there. Now you have to come up with an explanation of how the ocean can appear in front of something while not really being in front of it. I call that La La Land. Shout out, Messi.
I want to present something really quick. I know you're presenting something, Adam, but I'm going to take over you. This is just really quick. So I think I am going to take over your screen share, Adam, probably. This is a citation just because Gary liked throwing this type of comments. Gary just threw this comment a little bit. I'm going to use this as a citation. When earlier I showed something and Brian say, "Oh, that's perspective, man," and
oh my
like saying when I
God,
show images,
how
say,
stupid is that man?
Well, Gary Webenga says,
assuming Gary Webenga is a man,
images are pseudo perspective. Zooming images are not real perspective. Thank you, Gary, for giving me a good rebut for perspective, the perspective claim.
So what's real perspective? Something that's not zoomed in then, okay.
No, actually, in photography, we have, there's a really good way of thinking about perspective. Perspective for a photographer is the arrangement of the apparent size differences between things at different distances based on the location that you're at and the distance to the subject, the main subject of the photograph, i.e. the point where the lens is focused. Now, people ascribe all sorts of stuff to this because if you use a wide-angle lens and then fill the image with the same amount of the subject as you do with a telephoto lens, the camera to subject distance is going to be tiny with the wide-angle lens and big with the telephoto. So, of course, you're going to have to move the camera and the perspective will change.
You talk about like the ones that you took a photo of that inside that hangar with that plane and stitched them together later, or the one where you took it at that of the hall where you're outside, but where you used to go for your meetings?
It doesn't actually matter how you generate the image, because it's all to do with it's all to do with the distance relationships of the things in the scene. It's nothing to do with the lens that's taking it. So I can use any sort of wide-angle lens. We'll forget about the stitching because say you just do it with a really wide lens and then a telephoto lens. If you then print them from the same location, if you then print those images so that all the things, so that the subjects are the same height in the photos, and then you crop the print that you made from the wide-angle lens down so that it only shows the field of view of the telephoto lens, perspective-wise, there will be absolutely no difference in the two photographs. You wouldn't be able to tell which lens took which photograph. So it's real perspective. There's only one perspective. Also the formula still works. I mean, the angular size formula still works. It's just when you hear photographers talking about perspective, they're usually talking about the size relationships of the stuff in the image, because that's what's important to a photographer.
Okay.
Claim. Oh my God.
Great minds think alike. I was going to say, if you zoom in, you're saying the P900, sees better than the human eye. Yeah. Then you're zooming in. But still, why don't you take the 0.02 if that aperture?
Brian, I've got a question for you. Does zooming in on a camera lens alter perspective? Yes or no?
Until they started incorporating the 0.02 degrees, video games look retarded.
No, okay. I'll tell you what. Maybe
do video games, right?
Okay, so maybe I'll ask it again. to try and get an answer out of a flat earther that never answers because they want to live in La La Land. If I zoom in with a camera from a focal length of 30 millimeters to 300 millimeters, have I altered perspective? Yes or no?
You have shrunken my circle of. Now, when video games started taking into account the Raleigh criterion, they started looking more fucking realistic.
We don't understand you, Brian.
fucking
Shouting.
troll.
Yeah, it's too staticky. It's too staticky.
He's a troll, dude.
Calm
He's
down,
a troll.
Brian.
He tries speaking trickery.
Just to
when
correct
video
Brian,
games started
yeah?
incorporating the Raleigh criterion, they started being realistic. Remember Atari?
Okay, are you ready, Brian?
Remember Pong?
So,
Remember
are you ready?
video
Are you
games?
ready? Wait a minute, because one of us has made probably 20 plus console AAA titles, yeah? One of us, and it ain't you. And I'll tell you something right now. We never give a shit about the Rayleigh criterion in video games.
Then
It's
you
about
ain't in reality.
listen. It's about texel density, which is the relationship of 3D visual space to pixel representations, because the smallest unit is
Maybe
a
that's
pixel
why
on a
you're the
4D
runner-up
display.
then, buddy.
So
Maybe that's
the
why you're
issue
the
is,
runner-up.
just like Flat Earth, you're making up utter bullshit and sounding authoritarian, but you're just coming off like an asshole that knows nothing.
Maybe
really sorry,
that's
Brian.
why you're the follower and not the leader. Maybe if you listen to me, you might be a leader instead of a follower. And your graphics are shit. Your graphics are shit because you can't factor in reality. Okay? Now look at Commando with the top-down view. Back in 1993, 1990, Commando with the top-down view. Okay? And they couldn't show way up in the distance, okay? The better graphics have gotten, the more we're starting to show up in the distance. And now that people are with reality, this information starts getting out, and people start seeing, hey, the Earth might not be curved. If you would incorporate a 0.02 degree obstruction off in the distance around the criterion, you'd be with reality, and you wouldn't be a runner-up, buddy. You'd be a leader.
Jose, hot mic, Jose. So Brian, that was absolute fantastic.
Yeah, so you can start.
You showed your amazing intellect, and you showed your knowledge.
Things I don't know. Yeah, so let's discredit Brian now. Let's point out things I don't know.
Go on, get it out, Brian. Get it out.
Okay, let me get it out. Okay, what you're going to do now is you're going to point out things I don't know about graphics and computers. But what I do understand is about the perspective. And if you think it's wasting your time to make things join in with the ground at 0.02 degrees, then you're arguing with the Rayleigh criterion. And all you can do now is discredit me as a person. That's all you can do now is discredit me as a person. And separate you from Singular Productions.
Yeah, okay, you ready?
Okay,
stop.
If you want to make a video game,
oh my God. Let me.
Good. Your turn.
All right. So, Brian, I've got a question for you, and it's a really cool question because I need to learn from the master of perspective. If an object is 1 degree vertical in my vision and it's 100 meters away, and it goes to 200 meters away, how tall is it in my vision?
All right. You want me to pull up the fucking calculator? You've already got it up,
just tell me now.
Just tell me now. Dude, if I had fucking radiant fucking memorized.
A small child would answer that, Brian.
0.69? What, 0.69?
What was the question again? I missed it. I wasn't paying enough attention.
He said if it was if an object one.
Okay, we'll all be part of it. I can get to the spot.
Okay.
So Brian, I've got a question.
Here we go.
Question for you, and it's a really cool question because I need to learn from the master of perspective. If an object is 1 degree vertical in my vision and it's 100 meters away, and it goes to 200 meters away, how tall is it in my vision?
All right, you want me to pull up the fucking calculator?
Because it's gone further away, it'll be half the size, wouldn't it?
It's gone twice as far away.
Twice
so
as far away.
Size.
Yeah. He gave the simplest example he could think of.
Right, so it's half the size.
And he even asked it in degrees and not.
Double the distance, the size. It's half the size.
Right.
Yeah.
Okay.
Very simple.
Okay, even I figured that.
Similar triangles.
Okay.
Yeah.
I just thought
Think
if
of
it's
it that way.
further away, it's smaller, so it's half the size. Yeah.
You've already
No,
got it up,
just tell me
apparently.
now.
I mean,
Just tell me now.
if a triangle, dude, if I had fucking radio
The answer's easy,
fucking
Brian.
memorized.
A small child could answer this, Brian.
0.69? What, 0.69?
Right.
No.
Isn't that the small? This is small and that's far away.
No.
May I?
Yeah, go for it.
Say it
Anybody
again.
could answer that.
I would say somewhere about 3/4, if not more.
Yeah, it's 0.69.
Christ.
It isn't. You're actually
God.
both wrong. But anyway, the point is, a first
What is it,
year,
then, genius?
it's 0.5,
What is it?
dickhead. So,
Yeah, what-
a simple student of 3D graphics in their first day would tell you this, and they do it
Show
on
me
graph
a
paper.
0.5.
And this
I
is
was-
perspective.
I don't
Show me.
know anything about, you know.
Double the distance,
mathematical-
half the size.
Anyway.
It is really simple.
Okay.
That's what he does now, okay? But if you double the distance, you have to size. Then that's
here we
not
go.
inversing,
I
okay?
asked-
Then,
I
so
asked
there's
the
no
most-
inverse
what-
flip,
oh,
so
I'll tell you what.
discredit me, right?
Wait a minute. Brian, I asked the most simple
I'm
question
sorry,
that
let
there was
me back
regarding
off.
perspective. I asked the most simple question regarding perspective to learn from the master, and you have actually proven to be the master, but not a
Yeah, so
perspective.
discredit me.
All right.
I've proven you do what I said. You discredit me. Okay? Just like I said you would do. You discredit my knowledge.
I don't need to discredit you, Brian. You do that yourself by talking.
Excuse me.
No, Stingray, if I listen to him.
Shush, 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 shush. Stingray, did I do wrong?
You did wrong, yes.
Did
Yeah.
Brian do wrong?
I was closer than you, bud.
Brian did more wrong, but there is no close. There is only exact.
Well, what
like
do you
I say.
mean, no, wrong?
Okay,
he said
so
3/4. He said
was
3/4. That's a 0.69.
Shush,
We talking about he was
shush,
I'm more wrong.
shush. Okay, shush. So what was the answer?
So if it's one degree vertical in my vision and it is 100 meters away, at 200 meters, it will be half that.
Stingray.
Okay.
If you just listen. If you
Yeah,
just
that
listen to
makes
Brian,
sense.
Meters.
That makes sense.
What about 400
Yes.
meters?
So here's the fantastic thing though, Brian. The top of a ship and the bottom of a ship are both 30 meters high. Now when they go away, the top and the bottom of the ship double the distance. They will now be 15 meters perceptually. So we'll call it 1.5 degrees. They were 3 degrees.
Will they be
The
the
top was
same
3 degrees.
angle?
Wait a minute, yeah. The top was 3 degrees. The bottom was 3 degrees. Double the distance. Now they're 1.5 degrees at the top, 1.5 degrees at the bottom. That relationship never changes. The only way to block the bottom is put something in front of it. I want an explanation for that on a flat, stationary,
So our
motionless Earth.
vision,
Go.
our vision doesn't compress then, does it?
Is the
What do you mean our
horizon
vision
doesn't compress, does it?
What do you mean our vision doesn't compress?
Does
Let me
on the horizon
let me answer
does
for
everything
shush,
compress?
shh.
The definition of the
Let
horizon
me answer
is
for a flat.
basically
Yeah.
the focal point, a compression point.
Compression.
That's not what horizon
Right,
means.
does everything compress?
No.
You have to define
And compression is
for
a
me.
stupid word that
Do
nobody
I
should ever
lose-
use.
Do I lose focus when I drop less than 0.02 degrees? Do I lose focus?
Focus is
Don't elaborate. Don't elaborate. Do I lose? Okay. Do I lose the
Right.
ability to distinguish between two things at 0.02 degrees? I'm actually there's 100 ways to be honest.
With the human eye, yes, you do, but we're not on about that. We're about a lens, and we're about shit that's
Okay,
like
so a
1
lens.
degree, not 0.2, 1 degree, and we're even zooming in on
So a
it,
lens.
and there's enough pixels to display it. Woo! There we go.
That's good. That's great, bro. So something that disappears at 0.02 degrees in the human eye,
Human eye.
then we quit being
Human
able to
eye.
distinguish it.
Human
okay?
eye.
So is
Human
there
eye.
a point? Is there a
That's a human
point?
eye.
Is there a
Human
point?
eye.
Is there
Human
a
eye.
point with higher millimeters? With higher millimeters, is there then a point where that lens
Even Google
also
Translate's having
reaches
trouble
a
trying to.
point where the
Too much
low
distortion.
angle-
Yeah.
P900
I can't even
Are you
understand
ready?
it.
Are you ready,
Yeah, I know. I'm
Let me
trying to
explain
down
it.
as much as I can.
I'll explain it. I'll explain it. The Rayleigh criterion is based
You will
on...
be lying. I'm going to
Oh my
stop you
God.
from lying through
Let me
your
know when you're
fucking
done.
teeth, bro.
Let me know when you're done.
Dude, how are you going to say the human eye reaches a point of not being able to distinguish, but P900 doesn't?
Let it down.
I'm letting out you, bud.
Are you done? Are you done?
Because the diameter of the lens
All right, so
of a P900
Brian,
is
here's a
bigger
very
than the diameter
interesting
of a
thing.
human
The
eye.
human eye and the Rayleigh criterion, we have perception, and they're based off rods and cones. They're not actually based on the lens elements of the eye. They're based on the receptors of the EM, the light, as in our rods and cones. Now, in a camera, that's based on the sensor, which is made up of light sensing pixels. It's really easy. If there are enough pixels for the top of the boat, there's enough pixels for the bottom of them, because the relationship stays the same. Prove that wrong, or get another religion.
You can take and you can raise it. So if you lay your eye down on the ground and look sideways, okay, then you can. Let me finish. So you could lay your eye down on the ground, and you could lay a lens down on the ground. It wouldn't have to get bigger and bigger and bigger to see further and further and further.
What? That doesn't make no sense at all.
Right, so Brian, if I put my face... Oh, okay.
See further and further and further? Answer honestly, bud.
Okay, Brian, so if you take a ruler... Wait a minute, let me just finish this and then I'm done. If you take a ruler and you've got 10 centimeters, and each one of those centimeters you can see the top one and you can see the bottom one, and you move it away, they will all be the same size for the distance until you can't discern between any of them. It doesn't matter whether it's the bottom one or the top.
Okay.
If you're
One
above,
second.
if you're above that,
Matter the land?
flat Earth
I need to
dead,
jump
religion dead.
Okay,
Brian.
I need to jump in 1 second. I muted Brian. I need 30 seconds. I first want to thank everybody for being here. Still, you know, we got 80 plus people watching. Thank you very much. Very entertaining show today. Very diverse. 54 likes. 7. Now, maybe it's your static mic, or maybe yell, but you gotta. Yes,
a little better?
Yes, please, man. I know
Well,
you want
told me that to the show, dude.
Hey, you know what the key is? But maybe you want to just be heard, and you think you're gonna speak louder than what you're speaking, but when you get it closer to your mouth, it doesn't sound louder. It sounds more distorted. Is what it does.
I understand.
So it's still
What I
gonna
did is
be
I
the
just turned my
same-
headphones off.
Yeah, it's still gonna be the same amount of the same volume, higher or lower. So
What I need to do is turn my headphones off. Sorry about that.
Okay, yeah, it's not bad now with these last few sentences that you told me. So please, I'm willing to let it run another half an hour or so. I'm cool with it because it's entertaining, and we got a big audience. So this is good.
I'm still waiting on Leo's question. I'm still waiting on Leo's question too about the energy of water. But Motorola, whoop whoop.
Okay, Brian and all the I would say globe defenders. I would like you to go and try to convince, especially all the globe defenders. I would like you to go and try to convince Brian to the globe side more.
I promise you, I could argue the
Brian,
globe
please,
a lot better than you, bud. I can argue. Let me just say this one thing. I can argue the globe better than anybody on this panel. I can argue the globe. I've got arguments way better than that contort reality. Y'all have not reached that point yet.
Let me give you my opinion. Adam L.
Yes.
Thank you for your advice. I'm not from the globe side, nor I'm trying to convince anybody. So shout out to what you are trying to accomplish. Is not for me.
I'm trying to convince everybody about reality and progression of science and things. Whether the Earth winds up being a globe, you know, it wouldn't blow my mind, bro. It wouldn't blow my mind. But as far as science is stuck, bro. Listen, man. Listen, bro. We're still, because of people like you, we're still using combustion engines we invented in 1895.
Brian, I've done nothing but drive electric for the past 7 years. I don't know what you're on about.
Okay,
but you're stuck. You won't look at reality, bro. If you look at reality,
Brian, I look at reality every single day. It is my career to look at reality. I get paid very handsomely for it. I am not a follower.
bro, you wouldn't. You say it's a waste of time to make a graphic that disappears shit. Okay, a human perspective graphic that makes things combine with the ground at 0.02 degrees. If you consider that not reality, and you think it's a waste of time of doing it, that's why video games are fucked up, bro.
No, the issue with what you're
That's why you're not a contender. That's why you're a follower, not a contender.
The issue with what you're asking, Ryan, is that degrees is based obviously on 360 degrees orbital around your vision, actually in the Y in the Y direction. Now, with something disappearing at 0.02 degrees,
Z-axis, bro.
Oh my
I'm talking about the Z-axis. You're not even talking about what I'm talking about, bro. I'm talking about the Z-axis, man.
You jump in between, Brian. You didn't let him finish, man.
He's arguing with himself, Jose.
Yeah, but no, arguing for himself. He's trying to make a point, and I'm trying to hear him. But he got to mid his point.
Okay, Brian, that's zero. Wait a minute, let me just finish. Let me just finish this.
All right, Stingray's turn. Go ahead, finish.
Yeah, all I want to say is that Rayleigh criterion is based on degrees, vertical. Yeah, so imagine a vertical Y direction, Brian, and we divide it into degrees elevation, just like you would. Just like you. Oh my God. Just like you would.
Brian, let me hear it.
On a protractor, that's what it means. So what it means is a very thin slice of 0.02 degrees away from you in this cone that's going out.
But Brian, you're confusing me by interrupting. Please, man, don't do it again, bro.
So I can show you a million citations for this. So you show me one that says it's false, and you've won. Now, so the issue here is, with that 0.02 degrees being based on the human eye, let's imagine now we get a camera lens and zoom in. Now, previously, the rods and cones and our perception was incapable of discerning objects at that angle, that vertical angle. Except when we zoom in with a camera, we can make that vertical angle 100% of the pixel size. In other words, 21 megapixels high. To say that the camera can't... Listen, let me finish. To say that the camera can't resolve
just stop for a second. One has to remember that Stingray actually a lot of the time seems to have an idealized understanding of cameras and lenses, but I'll let that go. You don't even need the camera. All you need is a cheap ass spotting scope, because that will give you the extra magnification your eyes need to see this stuff. You only need the camera if you actually want to make a recording of the view.
Okay, I see your point there. Yeah, you only need a magnifying type device.
Yeah, I mean, I don't know. Over here, Aldi's used to sell a really nice spotting scope that went up to 60 times magnification, and in the middle, it was actually pretty dang good for 20 quid.
Is utterly fucking insane, you mad bastard.
Right. I'm sorry, and I might be a mad bastard, but you're looking at it in 2 dimensions. You're starting with Pong, working your way up to Atari, to Nintendo. It's the Z-axis, bro. It's not just going to be everything at 0.02 degrees on the Y-axis, bro. It's everything from the Z-axis. So everything at a certain distance from us, it's going to be a little more complicated, bro.
But it has to work on the Y-axis too.
Away from us on.
Works on both axes, or
it has to work. In fact, it has to work on all. It has to work on all of the axes, the X, Y, and Z axis.
Yeah.
Because angular size and all that stuff doesn't actually give a monkeys about direction.
No.
z-axis reaches a point of 0.02 degrees, it starts fading in with the ground. Then you can make video games that look fucking real, and you wouldn't be a follower, Stingray.
Right, just really quickly.
Okay,
I've got to answer that. I've got to answer that. My answer is quite simply this. I've done this for 18 years. I've taught people. I'm a professional in that field. You're a fucknut, and you're telling me what my profession is. Go screw yourself. You know nothing. And what you just said was utter bullshit and lunacy. Stay with your religion, dude. Good luck.
Okay.
I need to say 30 seconds, Adam. Then you go after me. This is the beauty of being a flat earther, that people see things that nobody else see. Even people that have dedicated their whole life, and then the next generation after generation, for hundreds of years, understanding optics and cameras and just observations. Gary Wayvenga sees things that is actually very easy, that he cannot believe that nobody saw it before. So shout out to the flat earthers that are seeing things that nobody, dedicating years and years and generation after generation of their lives, we haven't understand. But shout out to Gary Wayvenga, he got it down to the nail.
If that was true, what Jose just said, there'd be recognized flat earth type people out there now that are high up in science and technologies with their thinking. That be true? If what Jose said just then. Was I muted?
Can you say that again, Terry? Because my brain didn't process it properly. Sorry.
Jose just defended the flat earthers by saying what they think and what they bring to the table. To think different.
But they bring nothing to the table.
But in saying that, if that was true, scientists and technologies and that would be on their side already. If that was true.
Correct.
If that was true.
Yeah, I mean, if what they say was true, then our science and engineering would be based on that.
Yeah.
Unfortunately, it isn't, and it's not.
Yeah, exactly. So for Jose to defend them like that is not really what Jose should have done. That wasn't.
No, Jose's done what Jose needs to do to keep his channel viable.
Yep. That's why he flip flops.
Yeah.
Go ahead, Adam L.
Okay, so Brian, my friend, let us introduce you to the physics. The thing is,
start with video games. Start with video games and how they're just now getting where we can see out in the distance. And Stingray, I still love you, bro. Sorry to piss you off. I hope I got you thinking, brother. Hope I got you thinking. I hope I can progress you and what you do, so you can be better at it. And if I can't, I'm sorry to piss you off.
No, Brian, you didn't piss me off. No, you don't have to apologize. You didn't piss me off.
I am so
malice for you,
happy.
but I still think you're nuts.
I am so happy, Brian, that you stated your point. The thing is, I'm not playing video games for last 3 years, I would say so. The thing is, video games do not.
No, you're measuring plumb bobs, philosopher. Remember, you're measuring plumb bobs. You did that this morning. If I'd asked you when's the last time you played a video game, you'd have said, I played one this morning. Just like you say, I did a philosopher. I'll listen if you, be honest, did you hang a plumb bob this morning? Philosopher, did you hang a plumb bob this morning? Be honest. Did you hang a plumb bob this morning?
Adam was
Did you hang a plumb bob this morning, philosopher? Be honest.
Adam was talking. Let him talk.
Brian, you are being rude. You should go to...
I don't like being lied to, bro. I don't like being lied to.
Shut up, Brian.
Oh my goodness, Brian.
All right. I need to interrupt because I don't want the personal attacks. And I got a super chat, so this was a good break to stop the personal attacks. Try
go
to
for it.
attack to address the arguments instead of personal attacks. John Watson for £2. Stop freaking around, Stingray. Tell it like it is. Boom.
I think he's finishing off there.
John, here's an interesting thing for you regarding pictures and long distance photography. Very few, there's very few images that you can find of moonrise or moonset across water. But there's a particular place, Boston, where in some seasons, and I forget which, but you can look these up. You can see, you can go out to Boston and have and there's one photographer that does this. I forgot. I'll try and get some links. And he.
Stingray just said it's hard to get moonrise over water. That's what he just said.
I believe so.
I didn't think it was hard.
Yeah, that's what he said.
That's not true.
Yeah, I was going to say, I don't know why it would be difficult.
Yeah, because I
boring maybe, because you've got to find an east facing coast with something nice.
Well, I've got clear skies
in the foreground,
and moon's was rising last week, which I could have had a camera, took nice photos of it.
Yeah, on the coastal areas, yeah.
Yeah.
Moonrise or moonset across water. But there's a particular place, Boston, where in some seasons, and I forget which, but you can look these up. You can see, you can go out to Boston and have and there's one photographer that does this. I forgot. I'll try and get some links. And he photographs the moon, and he photographs it down on going behind the horizon. But what's really interesting about that is the angle that some of these shots occur. Something should be in front of that flat horizon, and it's called Nova Scotia, but you do not see it. But the moon is further away than Nova Scotia, and you do see that. So Flat Earth's got a big problem with this, but luckily, the rest of us move on with our lives.
Wow.
Cheers.
That was something new. I never heard about that.
Yeah, it's there's beautiful photos of, and there's only very few areas where I've seen the moon set on the ocean, where in that exact direction, that you should see another landmass, a massive landmass, which should be Nova Scotia. Obviously, the moon isn't in between Boston and.
I think he's forgetting about, I don't know, Lowestoft or Great Yarmouth, where the moon will rise, and I don't know, Holland. I mean, I know Holland's not particularly tall, but
yeah.
Or you could go down to the southeast corner to sort of the pointy bit of Kent, and I don't know. I guess the problem there is that France is actually a bit too close at that point, isn't it?
Yeah.
But there'll be spots along the south coast where you should be seeing France.
Where was the moon in your sky in the last several days ago? If you could see it, could have seen it.
If I could see it, it would have risen somewhere to the east of me.
Yeah, north of
gone
east?
up.
North of east.
I have no idea. I mean, generally, shit comes up out of the east side of this, out from behind the ground to my roughly to the east, and kind of goes up and over up and towards the south until it gets to its zenith, and then it goes sort of down.
You're saying it
down
goes
and
south,
back towards the north a bit.
You're going south of zenith if you're talking directly up.
Well, it depends on it. It depends on which bit I point the camera at, doesn't it?
Yeah, because if I use zenith in the context of directly straight up, 90 degrees perpendicular to my position. You're saying it's south of that. Now, when it comes up...
No, sorry. The moon specifically tends to come up towards... It tends to come up somewhere towards the east, and But of course, it depends on the phase, because as the phase changes, the point where it comes above the horizon changes as it goes round.
Yeah, it was a partial moon, and it was lower in the sky, in my north sky, from east to west the other night.
No. Terry, the moon's never in the north sky. The moon is always in the south sky.
Wait a minute.
Your sky is broken.
I hate it when that happens.
That's what's got me confused about what Stingray said. Nova Scotia is north of Boston.
Yeah.
Right.
You can't look from Boston at Nova Scotia and ever see the frigging moon.
Right. That's what it was getting me too. I'm thinking, no, the moon rises east.
The moon is south, is always south of your position here in North America.
And that's what I was getting at, and that's what I was going to say after you clarified, like directly straight up, it's south of that. And I'm going, no, it comes up east and then goes north of that, and it was even lower in the sky the other day when it was on your partial.
Like I say, here.
Well, you'll always see it in your north sky. And I'll always see it in my southern sky.
Yeah.
That's a weird one.
I'm going to say, and when it's a full moon, it always rises pretty much due east at sunset, goes up and round to the south, and then back round to the and sets in the west at dawn.
Yeah, give or take 5 degrees, because that's how the plane of the orbit of the moon is tilted.
I wish I had a decent camera to go out there and take these moon shots that I see come up over the horizon out of the ocean.
Yeah. You're in a beautiful spot there, Mark.
Yeah. Get clear mornings too, where it comes up over. Well, from what I can see, it's clear.
Especially at winter time, you haven't got all the heat waves coming off the ocean.
And we get enough cloudless days to do that.
In Stingray's defense, after talking to Brian Leakey for an hour,
I'll let him off with that for now.
The poor guy had to be close to brain dead at that point.
Yeah, I think we'll leave it at that. What do you do? Transition from that to that. See, look at that, Alan. You do that, and then you transition to that.
They go completely out of their way to misunderstand things.
Yeah.
And idiots like Liebinga. My God. Liebinga tried to tell me the other day that if I take a screenshot, okay, from somebody's video, take a screenshot, and just enlarge a portion of that screenshot, it's exactly the same thing as if you zoomed in with the camera that made the video to begin with, which is absolute bullshit.
What? Really?
If that really worked, we wouldn't even need a telescope. All you need is a cell phone. Just snap a picture of the sky and zoom in on anything you want. You can see the moons of fucking Jupiter or anything else.
Blue, that is
crazy.
That is technically true in a theoretically perfect camera.
If the camera had infinite pixel count, yes.
Yeah, no, I'm just saying that it's like I was saying about how we talk about perspective and it's nothing to do with the lenses. That is only true if you've got perfect lenses and an infinitely high resolution sensor.
Right. If you have a sensor with infinite pixel density, or a film with no grain whatsoever.
Yeah, if you have to have unlimited resolution from your perfect lenses, and unlimited resolution from your sensor.
But if you zoom in, you see the pixels on the TV, so it'd be all blurry.
Sorry, what?
Yeah, if you took a photo.
Did I mishear what? Blue, sorry, I thought Blue just said if you took it.
Yeah.
Are you filming this? Are you filming this on the off? Are you doing like some people do and filming your TV screen and zooming in on that? No, that won't work at all. That's an even stupider idea.
Yeah. You're zooming on the pixels.
You can't retrieve more information than it contains.
True.
It has a finite amount of information in it.
Yeah.
And you can't get more than that back out.
It's like on those movies where they get a grainy picture or whatever, and they go, okay, we'll throw it in the computer and we'll enhance it and zoom in on it.
Yeah.
And then all of a sudden the picture's becoming clearer and clearer.
Well, Vroomfondle makes a good point in the side chat. Gary must think that Blade Runner is true, because if you remember in the original film, he finds some photos and he loads them into his computer and he zooms in and enhances and moves around in the photo and does all sorts of impossible things that you just can't do. And they weren't even digital images. They were actually hard copies of photographs that he loads into his computer, and then he enhances and does all sorts of weird things that's, well, impossible.
Well, I think we've been going nearly long enough, except for Blue dropped something. Is that a new thing, Blue, you dropped?
Yeah, it's just a quick piece of fairly raw video of the Cavendish.
Yeah, okay. And then Alan can explain to me why OBS mucked up on me again today.
There's no sound on it, Terry. It's just
Oh,
video.
Okay. Or you can
So
talk.
you can just play it and we can talk.
Okay. You can see the pictures and you can talk then.
Sure.
Transition, like Alan said, try the transition thing. I want it to fade. That'd look more cool. If it faded.
It does, but it's a really quick fade.
I got it at 300 milliseconds.
Well,
yeah, you need it to be a bigger number.
Pardon?
Very quick.
300 milliseconds is really quick. It's less than a second to do the fade. But
so what should I have it at roughly? Less?
1,000.
Bump it up to 1,000 or 1,500 or something like that.
Okay, does it go?
Yeah, 1,000 to be fine. That's a second.
That's 1 second. Yeah.
Okay, 1 second. So just add noughts to that because it won't go to that. So I'll have to add a nought to it myself. That's 100. One more nought. I may as well do this on the fly so that way I've got it done. Okay, that should save. So if I transition, still seems quick.
Well,
I'm watching it. Where will I see it do it? Out on YouTube?
Yeah.
Oh, I won't see it. Because I got it at 1,000 milliseconds fade.
Yeah, you'll see 1,000 millisecond fade, but mostly out in YouTube land.
Oh, okay. Oh, bugger. I'm not going to be able to see it. What's that on the bench, Terry? Hello, all. Hey, Tony. What's the matter, Scott? Scott's that on the bench. Something's on the bench that he's saying.
I don't know.
I know what I'm going to be looking for, though, but I don't know what Scott's talking about. There we go. They should be seeing it out there, I hope.
Yeah, they are.
Are they? Oh, okay.
They're seeing it. Yeah. Mm-hmm. Yeah, well, I finally got all the parts and pieces screwed on there.
Looking good.
Yeah. I don't know if you guys, if that's the stops on the install that prevent the lead balls from becoming wrecking balls and crashing.
They'd do some damage, wouldn't they?
Yeah.
Oh yeah, absolutely. Got those cute little thingies there that position them exactly where they need to be, so that they're just opposite the small weights inside.
Oh yeah.
And I made provision so I can adjust those stops a little bit. Stuff like that. Looks better out in YouTube land than it does on Zoom.
Oh yeah. So
Pretty
it
jerk.
It gets a bit laggy, doesn't it, with video from YouTube?
Yeah. The pulley.
Ah, the pulley.
The pulley and the paracord. That works.
Go up a bit higher. I want to see the end where it goes around the bit where you made there. Up, over.
Oh,
now it's moving. Oh, it's magic.
Yeah.
That's moving by itself.
Yeah, I never quite made it up to the guide up there. It's. I got another video of that, making that guide.
Yeah, where it goes, the rope goes through. Yeah.
Yeah. I got pictures of it if you want to see them.
Mhm.
I'll stick them in the. Let's see. Check it out.
Ball's going up.
Uh-oh.
Uh-oh.
I dropped out for a second for some reason.
I see what that noise was.
Don't know what happened. I bet they'll go back the other way too.
What goes up must come down.
Or maybe that was the end of it. I don't know.
No, still got a bit to go.
No. I'm moving the camera around. That's...
All right.
Here we go. Ready?
Mm-hmm.
Come on. Pull on it.
Like a big kid with a new toy, really, aren't you?
It is. That thing's fun to play with. I stayed out there for an hour. Just watching those things swinging around. And there they go. Right up in their little notches.
Yeah.
And that's the end of that.
Do they touch? Does the rod actually touch the notch in any place, or is it?
Yeah.
Like a hole
It goes. No, it goes solidly up in the holder. Hang on, I'm gonna transfer these images. If I can find them. I'll stick them over in Discord.
Well, Oregon University would be interested in your contraption. Yeah, for students and stuff like that.
It's not a contraption, John. It's a scientific instrument to test.
I'm talking farmer talk here.
Oh, okay.
Well, if you're talking farmer talk, it's a what's it? A contrivance.
Contrivance.
Good idea. Florida's been playing with Lego. Dropped a video. My reply to Rukia review. It still transitions too fast out in YouTube. Like it just switches straight away.
Well, 1,000 milliseconds is 1 second, and I see a 1 second transition, and I think it takes forever. So,
oh, okay. I'll leave it at that then.
But you can set it to anything you like, Terry.
Yeah.
I'm just saying, what that. You can set it at 1,000th of a second steps, so you've got plenty of options.
Okay. The effect I want is that fade, where you actually see the image on top of one another slightly, and then it fades across.
I don't think it's doing across. I don't know what the exact type of fade is, because there's several ways you can do it. You can do a fade to black, you can do a fade to white, you can do a crossfade, and I don't know what.
Oh, you can do a cut or a fade.
Yeah, or a swipe or a slide or a stinger or a fade to color or a luma wipe.
No, it doesn't say that here. It just says fade to black, cut or fade.
Fade to black. Always fade to black.
Yeah. Oh, unless you're doing a crossfade.
Fade to black. Metallica. Ride the Lightning, 1984.
Try that. That might work. I'm still not seeing it. Anyway, I'll leave it.
Brainary, that's naughty.
Why? What happened?
He suggested a 5-minute fade time.
300,000 milliseconds. Yeah.
Funny. Okay. Back to that. All right, where am I going? What am I doing? What's happening? Where am I? Down here. Okay. Put some pictures somewhere. Okay, open them up. One. 2. 3. 4. 5. Oh, here. I'm up to. That was 5. 7. 8.
Hey, Irish, don't knock it. It's not that bad. Fade to grey. That's old Midure, isn't it, out of Ultravox?
Did you watch the video I made about making the rope guide?
I think I did. I might actually play that, a bit of that.
Want a link to it?
Isn't it in here?
No.
Isn't it in the
Well,
isn't it in
I don't.
your
No, I don't
special
think it's on. It's a YouTube. It's a YouTube video. Unlisted.
You didn't put it in here. Yeah, making the rope guide. I've got it. I've got one here. That's in your thing.
Oh, you got it.
Yeah, making the rope
Making
guide.
the rope guide movie. Yeah. Okay.
Yeah, it goes for
Okay.
17 minutes.
It's time to make the guide for the paracords. Yeah.
That one.
That's the thing. There you go. First thing I want to do is cut a rebate. This area that I've hatched out here.
Focus.
I want to remove that wood.
I didn't know that.
That's going to form a place for this to sit up on top of the frame. And then I want a smaller rebate up here on the top side with a little piece of 3/4 inch wood glued to it with some holes in it going this direction. And then when we finish this thing up, I'll cut this off at this line here and round this edge so that the paracord will come through the hole in this short piece of wood back here.
Yeah, it's focused
and just wrap
perfectly
right
on the
around
vise.
that smooth edge so we don't fray the paracord. So that's the concept. So let's cut this rebate. Let's do it using some old technology.
I bet you're going to use something to do with rabbits.
Yeah, absolutely. When you get this thing in the vise, get it nice and tight, like so. Good. So I got this thing beaten on it, which is a Stanley number 78 rebate plane, and it's got a cutter, as you can see here on the bottom. And that cutter cuts all the way over to this surface. And it's got a stop on it, a guide, that keeps us lined up with the side of the board that we're working on. So I need to set the width of this. I've already marked a line on my workpiece here. Actually, I did that with a cutting gauge. That gauge has got a knife edge in it. And it severs those fibers on top so they don't tear when I start this process. But let me set this real quick. Need to loosen this shoe up just slightly. Set that thing right on the line. And it's been a little cantankerous, which they can be sometimes. Damn, things will drive you crazy. So let's see how that is. All right. Let's see what it does. There we go. That worked. Right on the line. Even a blind hog finds an acre.
How much would you say you're shaving off each stroke? Guesstimate.
Probably 4 or 5 thousandths.
Okay. I was just going to look.
It's
at your
pretty thick.
Yeah, I was looking at your.
Yeah, that's
at your shavings when you took one off, but I didn't see it.
Yeah, when you're going with a grain like this, you can take a pretty heavy cut. It's
there it is.
It would be a really heavy plane cut, but you never do that with a smoothing plane or something.
No.
When you're trying to just cut a rebate, who cares?
Yeah.
Especially when you're just trying to get down
Sometimes
close to the
the
final
chips get
depth.
up inside the thing.
And obviously the thicker the pieces of chips is what you call them chips. It's harder to push.
Yep.
It's hard to push.
Yep.
That's why I was saying
Like
in
a truck.
comparison to a jointer, like making a rebate for a door jam or something. It's basically a manual version of that.
Yeah. Kind of like to push it all the way through. Don't stop in the middle somewhere.
Yeah. Get a full straighten.
Yeah. You can't always do that. Sometimes it just hangs up a little bit.
Yeah. You're going down about halfway, aren't you, to the thickness?
Oh, I don't remember how deep I went with it.
You got the stop guide.
Not halfway, but
you got the depth guide set there.
I
Yeah.
see what's doing it.
Had it too low in the
Down
vice.
against the
The
bench.
shoes.
That's why that outside edge is
You
acting
don't want
up
to
the
take
way it
any off
is.
your bench.
So let's see if we can raise this thing up.
No, it's just that shoe
Up
was
to the
riding on
limit.
the edge of the
Yeah.
You
and
see
cocking
what's
the
going
outside
on?
of it up.
Oh.
Yeah. Things all cockeyed.
Sometimes it just takes a minute to figure it out. How's that? Ah.
And sometimes you never do figure it out. There we go. Now it's just shaving the outside off because that's okay. We fixed it.
Yeah. So it was a little bit of an angle, was it?
Oh yeah, quite an angle.
No one would have
Kept
known
looking
if
at
you,
it.
if you didn't tell them, Lou, what happened.
I kept looking at that thinking, what in the hell? I've never seen this thing do that before. That's actually kind of handy
If you wanted to,
to know
do
you
that.
could do that if you ever wanted to.
Yeah, if you wanted to. And you know, I would have cheated.
Now
I would have had a
I'm liking that a
longer
lot better.
piece. Put it out through the table saw, cut it out, finished it off with a little bit
I
of a
think we're
plane.
down to depth.
Maybe I would have used that just to finish it off.
Oh, sure.
Then cut it to length.
Yep. That's okay.
Yeah.
All the way across. Okay.
No, I haven't got a rabbit plane here to do that. Any of that
Now
stuff.
we need to do the other side. And this time, let's see if I can clamp it in the vise like that, because I'm not going very deep. I need to reset the depth gauge, the cutter depth, to about 1/4 inch, like
What's
that.
that in English? Quarter, 3/8.
6 millimeters.
And I need to reset the width of the cut. So this 3/4 inch line that I've got on here.
15 mil.
Come on now. Time out. Sorry about that. Mrs.
What happened?
Blue
You
has
had
been to the
blackout?
grocery store. Okay, where were we?
I
All
don't
right, we
know,
got the
where we are.
depth stop right here set. And we've got the width of the cut set.
Oh, Stewie had to get
Turn that
technical.
camera
Lou.
just a little bit.
6.35.
Yeah.
And this time
Yeah.
I don't think the shoe, this guide, which got down on top of the bench the last time, that won't be a problem this time. So let's see if we can get this thing to work correctly. Yep.
it's just fun working with hand tools.
You hear that sound when it cuts? Like the sound you'll always make a nice sound.
Yeah, that sounds good. Let me stop talking.
And different wood makes a different sound too. Oh, getting the high pitched sound in there. That's all. Screaming in pain.
Yeah, you get a pretty good look at those shavings on.
That's down to depth.
Yeah.
Nice clean cut. Oh, that's what
I
we
guess
ended
you
up
could do
with.
that on a table saw any quicker,
There's a little
too.
bit of
Yeah, but I wouldn't be able to clean the cut up very neatly. I'd
Yeah.
have to do it by hand, like with a chisel, and just scrape along
Right.
the inner joint where it meets.
Yeah, because they won't meet at right angles, the way saw blades are made.
Yeah, and if I do it too deep, I'd end up with an undercut on one edge, and that's what I wouldn't
Right.
want. I'd want it to be
Yep.
a nice meeting corner, so I'd have to finish it off
Yeah.
with the hand chisel and
Yeah.
slide it down it.
Yeah, so,
stuff
truthfully,
here where I was having trouble. So I'll tell
I got sharp chisels here, not like at the men's shed.
you how we fix that. Let's see if I can do it the other way, where you can see it. I'm going to take a shoulder plane like this, hold it up tight against this side. Whoop. First thing I'm going to do is tighten that vise up.
yeah, that'd be a good idea.
Hold it up tight against this side and just run this little shoulder plane a few times. And that squares that up absolutely perfectly.
Mm-hmm.
While I'm doing it, I may as well do it on this one too.
Yeah, you must do that.
It was pretty good, but sometimes truing them up a little bit doesn't hurt. And there we have it.
Not finished yet though.
Just like the picture.
But wait, there's more.
So,
But wait,
I'll make a cut on the table saw, rip this part off, and then we'll come back and chuck this thing up in the vise.
It's a very small piece to
And
cut
I'll
on
show
the
you how
table
to make a
saw, but
round over
yeah.
just using a hand plane.
Yeah, I could have cut that with a handsaw just as easily.
Okay,
Wow.
cutting operation is complete. Now I want to round that corner.
the plane.
So I want to put it in the vise
Yeah.
like this,
Yeah.
where I can plane down this right side.
And you have to be able to get at it, don't you, once you're in the vise?
Yeah.
Now I can watch where I am.
Put that.
See how quickly you can do this without having to break out the router bits.
Well, the amount of curve you want on that, I don't think a router bit would really be much benefit. You'd have to have a big router for that curve.
Yeah, you
want.
got to. Yeah, it takes a pretty good sized router bit to do that.
Yeah.
Fiddle around getting that thing adjusted and all that stuff.
Yeah, just for that small
Number
bit of wood,
4.
it's not worth it.
Smoothing plane.
And I would mention too, Blue, that when you're doing the cut on that piece there, you wouldn't be taking a lot off with the setting that you'd have to start with, because once you get to the more wider bits that you're going to start to cut, you'd be fighting to push it, because it'd be trying to take too much. So you'd probably be starting with a really a less depth cut each for the first off.
Yeah, it's taking a pretty good bite at that point.
Yeah.
Because you're such a narrow little part of it.
Yeah.
And you're nowhere close to the finished part anyway. So just get it down and get it close, and then you'll see me do it here in a minute.
Yeah.
Tell you what, that's going the wrong way. I'm gonna have to turn it around because of the way the grain is running. I'll just have to do it from this
tearing
side.
the grain. Yeah.
Tearing the grain out.
Can't help that.
No.
Oh, that was pretty good, right? Finger? Not too bad. It's actually better.
All I'm doing is just holding the plane at about a 45-degree angle, and now I'm down close to that line. Should be the same on the other end. I'm going to take a little less bite with the plane now. Not that much less, dummy. And then just start working my way around it. Ouch. Yeah, ouch.
Anyone want to replay?
Yeah, do it.
Hey, look. When did it happen?
Working my back up a little bit, isn't it? Should be the same on the other end. Yeah, play it from there. You'll get the ouch. A little less bite with the plane now. Not that much less.
When you can start to go to town on it, that's when it happens.
Yeah, every time.
Yeah, going to town on it. Here we go.
Working my way around it.
What's going to happen there?
Ouch.
You can see the plane getting closer and closer to the end there when it just happened. You could nearly predict it.
Yeah, I just pulled the nose of the plane off and then caught my finger.
The bit of wood's not as long as your stroke was. Must be close.
I'm getting happy with it, I think. See how the other end looks.
Yeah, just look.
Really good. So there you go.
There you go.
Now, of course, it's not perfectly smooth, but we can fix that real quick with a scraper.
Scraper?
And I've got some rounded scrapers somewhere.
Okay.
Have a look real quick, see if I can.
So not a pre-profile piece of wood with a bit of sandpaper in it that you could run up and down it?
No, don't have anything. See if I can see where they are. Okay. You do it with just a flat scraper if you want to. It'll just take the plain cuts out of it. And that and a little sandpaper. That's about the right.
Oh, okay. It's just got a curve.
Yeah. I've got lots of flat ones, various thicknesses. And you turn a hook on the edge of the scraper. I like the blade in a cabinet scraper.
And that hook will just shave off a tiny amount of material. They're really good for
there we go,
smoothing stuff out.
A little bit of.
So that got most of it.
Now the sandpaper. I knew the sandpaper was going to come on the ring.
220 grit sandpaper.
It's sandpaper or wet and dry?
That's wet and dry.
Smooth as a baby's bottom. And there you have it.
I use white paper for sanding for woodwork.
Yeah,
that's
what we wanted.
Color.
Well, that was pretty much real time.
Good, huh?
Yeah, it was. Yeah.
I mean, there's a little bit of editing or a little bit off time with the camera, but you saw pretty much the whole process.
Yeah.
You really won't do it any faster with machine tools.
No.
By the time you fiddle around with everything.
Now, I don't know what order I put these in, Blue. They might be all over the place.
Oh, they're just
random.
Close, far away. Yeah. Just a few snapshots. You wondered if it touched. Now you can see.
Yeah.
That's the way the rod sits in that.
And the little nut and bolt setup here is your adjustment setup.
Yeah. I just fashioned some slots in the board so I can move it a little bit if I want to, or as you need to.
Yeah.
Because that's the kind of clearance I'm looking for right there. I want them to get as close as I can. So you wanted to see, there it is finished. Okay.
Wow.
Paracord wraps right over that rounded edge we just made on that piece.
Yeah.
Could have made that all as one, but I decided it was easier just to do what I did.
Yeah, because you would have had to rebate up here and then round off.
Yeah, that becomes a.
I agree with you.
Well, if you do a decent glue joint, it's stronger than the damn wood would have been anyway. I'm happy with the way this thing's turned out. Tomorrow I'm going to move around. Probably move everything in a damn shop. Try different positions for all this stuff. But, and it's time to put the tongue oil on everything too. I've been putting that off long enough.
That's the adjustment screw. There we go.
Yeah, that's exactly how Cavendish did it. It's simple and just absolutely brilliant, really. The arrangement that guy came up with.
Oh, I have to close all these tabs. I don't want to be caught using all these tabs. People will think I'm doing flat earth research.
Sorry.
There we go.
Tony has a beautiful turn of phrase.
Yes.
I don't know what it was. When I was trying to shill the channel earlier, I kept I put a post in the live chat, and then it didn't show up in the chat as me.
Oh.
Why does Tony talking double negatives? There is nothing about this that isn't impressing me. Okay.
In other words, it impresses him.
Yeah, I know.
Yeah.
That's what I'm thinking. Why do you have to write it like that?
Because it's a nice, fancy way of writing.
Alan,
That's
what's your
enough to
problem?
make people.
Just trying to think. Oh, okay. What happened?
It's like when somebody says you're not wrong.
Yeah.
You sent me a Oh, that channel. I don't know. That
Yes,
could be a
that
flat
channel.
earther. That could be a flat Earth channel. How do I know? How many subscribers have they got?
2. Last time I looked.
As much as that.
Me, and thee.
And me.
No, sorry, tell you right.
No,
there
me.
there was 3. There was 3 because Turquoise Laura had also subbed.
I was your first subscriber.
I know you were. Thank you. And Peter was threatening to sub as well, but I didn't check the.
Where's somebody seeing a gorilla? Oh, that was John's thing.
Yeah.
Sorry, I must have missed something.
That was the drumming gorilla, wasn't it?
Yes.
Doing oh god, was that a Cadbury's advert for what was he playing? Genesis, I think.
Yeah, there was definitely some Genesis.
Coming in the air tonight, if I remember rightly, because it's got that doo-dum, doo-dum, doo-dum drum beat in it, and I'm sure that's what he's playing.
Spot on, mate.
Yeah, actually quite a good advert, which makes a change because 99.9% of all adverts are shite. Well, they are. That's why I try not to watch live TV. I record everything so I can skip through the ad breaks because it's all nonsense.
Are you sure you didn't put in? I don't think you put in enough decimal points there, Farmers.
Well, yeah.
in the approaching to 1 thing.
Well, yeah, no, fair enough. But yeah, I mean, if you actually watch adverts and pay attention to them and read the small print, it's all lies. It's all bollocks. Or they're just advertising stuff that nobody wants anyway. Or they're patronising you and insulting your intelligence. Like, have you got indigestion? Picture these little cartoon firemen. What?
Yeah.
Really?
But it must be working, Farmers, because you're now picturing the little cartoon fireman.
Yeah, that's out of hatred.
Yeah. Especially as they use firemen dressed as foreigners.
Yes, they're not even English firemen. But I also find that some ad campaigns are so bad that I will refuse to either buy or use the service they're advertising. Just out of spite, if nothing else. Like, go compare. No, I refuse to. And it's a shame because sometimes, and I'm thinking of some of the classic Guinness adverts and some of the Honda adverts are actually clever, intelligent, funny.
And make you think.
But these days, it's all just rubbish.
Yeah, I started trying to watch something on the My5 Channel 5 player.
Oh, yeah. Yep.
Yeah, of course that puts in all the bloody adverts, doesn't it?
Yes, that's what I've done.
I stopped watching that after I was about halfway through the first program.
Do you know what's ruined ads?
What?
Political correctness.
Political correctness.
Yeah, that's ruined ads.
Yes.
You could have ads back in the days that were funny.
One of the all-time classics, and I don't think it ever got showed over here. I think it was a VW advert with a little girl, and she kept saying bollocks.
Okay.
Have you seen that one? She's got like an ice cream, and she tips her ice cream ever so slightly, and it falls off the cone, and she goes, "Oh bollocks!" And she's doing a painting, and she knocks over the bottle of water, and says, "Oh bollocks!" And all the way through everything that's happening, this little girl's just going, "Oh bollocks!" And then right at the very end, she's sat in the car, and her dad is at the petrol forecourt, and I think it's a diesel VW, and he's putting petrol into a diesel, and you just hear him go, "Oh bollocks!"
because that's where she's got it from. It's a brilliant little advert, and I don't think it was ever allowed to be shown in the UK because she's saying bollocks.
Yeah.
That's got a very similar theme, but even though it's not the same type of ad, to one we've got here for the Toyota ad that was played a few years back, and it was Bugger, and the dog went to jump in the back of the 4-wheel drive Toyota, and he took off, and then the dog falls flat in his face in the mud, and he goes Bugger, and the missus goes Bugger, and a few other things in the ad, and goes Bugger. Yeah.
Yes, I've seen that one. Yeah, that they'd never showed that over here either, not in a million years. But I mean, even so, the Honda advert with the guy singing, the guy with the tash, and he's singing, and he starts out on the little sort of moped thing, then he's on the motorbike, then he's in different cars, and they're all Honda products, dreaming the impossible dream or whatever. That's a good advert. That the advert where it's all bits of the Honda going down the line, knocking this onto that and all the rest of it, that famously took 618 takes or whatever because there's no computer graphics involved. That's a good advert. When you got some celeb trying to flog you something and telling you it's got pro vitamins in it, no, you can piss off. There's no such thing as pro vitamins.
We don't call them vitamins, they're vitamins, mate.
No, we've just been posh. Well, I think we might finish up, boys and girls.
Yep.
How long we've been going? Oh shit, we've been going for 4 hours and 11 minutes. Oh, thanks, John. Thanks, Farmer. Thanks, Alan. Thanks, Big Blue. Who do we have out there? Renee, me, No Name, Stewie. There's Tony out there. He could have ducked in and said g'day. Brainery, No Name, Florida. Vroom Miro, Zebulon. UK time lapse.
That's it. Got to shield the new channel. UK time lapse 4K, because all my time lapses will be being re-rendered in glorious 4K and put up on there.
4 subscribers, right? We better make it 5.
Yeah, make it 5.
Make it 5.
Did you put the channel out there?
Yeah, I put the link in as I put the link in as me. I can put the link in as it now as well, can't I? I've just realised that.
Yeah.
Because Terry made it blue.
Hey, you've got 2 spanners. That's not fair. I'm gonna have to get rid of one.
I haven't got any spanners.
Yes, you have. I bet
Not
you
near
have. I bet you have.
Are you suddenly going to change it?
Type out there. Does it come up on your YouTube chat that you've got a spanner next to your name?
Just did.
Oh dear.
I typed in "have I," and then as soon as it appeared on the screen, the spanner suddenly appeared. That's magic, that is.
Because that's what people would do, and it wasn't kicking in the other week. And I'm going, what's going on with bloody YouTube?
Well, actually, yeah, just because I've got the chat sort of popped out in another window. It's still not actually showing me as having a spanner, but obviously I have because it's just
there.
That's weird.
Well, like I said, I had the same. I have the same. I have the chat popped out in the window so that I can try and keep a bit of an eye on it. But when I first started posting stuff from the time-lapse channel, it wasn't coming up on my other one.
Right. I just shut down the window and popped it out again, and now it's appeared. So you obviously had to do some sort of refresh activity to make it.
Yeah. The funny thing was I was seeing other people's posts, but not the posts from the.
You weren't seeing your own post.
I wasn't seeing the post from my second channel.
Oh right.
That's odd. That's weird.
Well,
that's why I put that question in. Can anybody see this post? Because was like weird.
No, that explains the question. Because I thought, what's he on about? Of course we can. But you couldn't.
No. It was almost like being blocked, because when you're blocked, you keep on typing, can't you? And you see it and nobody else does.
Oh, what you mean? For a while when I was leaving comments on Anthony Riley's videos and wondering why nobody was reacting to me, then I realised he's got me blocked.
Yeah.
Have you guys said goodbye yet, so I can say goodbye?
Goodbye.
Bye.
Come to Discord, everybody. See ya.
Yeah, go to
Bye.
Discord.
Okay.
Then you can hear the guys talking and talking and talking and talking and talking.